Wait, what? What? Excuse me? It reproed over here. Oh, that's without -x64? Why would that matter? No, don't do that. Don't do that. So we literally just did this. I don't understand. I don't understand. Also, yeah. All right, so 68. Okay, I think that fixes that. Indeed, it seems to. Okay. Let's look for more weird problems like that. How's it going, people? I might do some caffeinated tea, even though it's 7:30 p.m. I had a big nap today. I've got that thing where I took a nap and I slept kind of heavy during the nap, and now I just seem kind of heavy. You know what I'm saying? So I'm just going to run a few more randomizers here and see if we hit anything. I should have done these before shipping last beta. Didn't do that. Oops. Oops. Oh. Just run it. Oh, there's one. 768. Wait, it's in the same place? Wait, what? Did I maybe not really fix the 711 and it seemed like it? Because that was the same problem. Maybe I just got lucky. Or maybe 768 is different. I don't know where to get good banana bread. I like it sometimes, but you know, to be honest, I don't really like when people put like nuts and stuff in bread. Like that, those two things should not go together. And yet most people who make banana bread put nuts in there. It just, I can't tolerate that. If it doesn't have nuts in it, then it's okay. Weird. All right, let's try reproing that here. I kind of feel like it's not going to. But we'll see. It did. Oh, that's very good. Okay. Desk arguments block. Oh, because desk is not queued. So what is this for? Like, let's see where this is. So that's line 283 of OGL. Line 283. So this struct is not ready. We don't have a site variable. We can go progress calling site. Wait, progress generating call. That's what it says. Generating call. Progress generating load info short name. Same file, line 310. So we're doing array add. We're trying to polymorph this thing. This is not ready yet. So it's one of the variables. So we're doing this thing where we're trying to do check for yield, and we add to this need infers array. I think we could just do this. I mean, the problem is that's actually inferred. Okay, so then we're going to take this out. This was not really the best way to handle that. Oops. No nuts in your banana bread. That's very good. Blueberries, I don't know if I feel like blueberries is acceptable in banana bread, but I don't know if I've had that. Do I like chocolate in my banana bread? Yes. Yes. Basically, okay, what happens is we try to make an array of all the things that need to be inferred before we could continue this polymorph, because if we go try the polymorph again later and all these things aren't ready, then there's a cost to trying that polymorph, right? And so we don't want to try it until we're ready. But the process of, like, we were assuming that the arguments block of this struct existed. And it didn't even exist yet. Need to return because the arguments block the arguments does not exist yet. I mean, maybe it just doesn't. Do we even know if it always is necessary? Let's do even one more thing. Let's go, because I feel like we might not actually have one sometimes, and like that's a whole other thing. Oh, you know what? Let's try this. Let's try this variant. Yeah, Emacs is not fast at the syntax highlighting. It's an open problem in computer science, how to syntax highlight. So here's the thing. I was having a talk with some older friends of mine about how fast computers are, right? And I just want to go through these numbers for you, because they were asking, like, how do you make the compiler fast? And I was like, it's not really fast. It's just not slow, right? And I was trying to explain to them not slow. Like, so your desktop machine, let's run through this again. A desktop machine from the past couple of years, like the one that I'm using here, it was not particularly expensive compared to, it's not a supercomputer, right? It's just a desktop tower. I don't know why they're called desktops when it's a tower that sits under the desk. So, you know, CPU maybe has like 8 cores or something now, right? Each of these cores has hyperthreads, but we'll ignore those. The clock rate is maybe in the 4 gigahertz range, right? And it could do 5 instructions per clock. So it could do 4 gigahertz, 4 billion operations per second, right? Times 5 instructions per clock, which is 20 billion instructions per second, times 8 cores, which is 160 billion instructions per second. And that's, you know, don't even think about the GPU yet, which could do way more than that. That's just like your CPU can do 160 billion operations per second. That's a lot, right? And so when you ask, like, how long should it take to syntax highlight a file? If it takes a second to syntax highlight a file, does it really take that many billion operations? You know what I'm saying? Not all cores can run at 4 gigahertz. I mean, in a well-cooled desktop machine, they can. Like in a phone or something, they'll throttle. Right, phones are a little bit different. But, you know, also, so like if you're thinking about syntax highlighting, you probably don't want all 8 cores to be working on syntax highlighting. So just 1 core, right? So just a mere 20 billion operations. Does it really take 20 billion operations to syntax highlight your file? If it does, something's probably wrong, you know? Just going from first principles like that is worth a lot. 60/60ths of a second to color a 500 kilobyte text file. I know, it's absurd, dude. And like only part of that text file is on the screen and very little of it changed, right? So you knew what the syntax highlighting was a little bit ago of almost the entire file. So what's going on there? Doesn't Borland C++ compile like 900,000 lines per second on a modern machine? Probably. Like the thing is, the more features you add, the slower you go, right? Like one reason why we only go at 230,000 lines per second right now is just because we have a lot of features that are slow to implement, right? We could run much faster than that if we deleted some features from the language. Would I enjoy having a conversation with Shakespeare? No. I think he would smell very bad due to having been dead a long time, and that would be very distracting. Yeah, text editors can't possibly frust them, Cole. There's no way to know where things begin. It's very hard to do a one-dimensional frustum call. Yeah, I haven't even run a water-cooled PC in a long time. I had one at one point. But just my normal air-cooled PC is like fine, speed-wise. But yeah, it's just important. Like most programmers don't, like the people I was talking to make a lot of money working for a large tech company, right? But they don't ever think about these things because they don't need to do that at their company, right? And it's like very few people understand. Like I'm not even a performance programmer, guys. Like I do not micro optimize things at Rad Game Tools, okay? Would I enjoy having a conversation with Shakespeare's ghost? It depends if it's a cute ghost like Casper or if it's like Slimer from Ghostbusters. Those would be very different experiences. Is water cooling really worth it? I don't know. There is no widespread demand for totally optimized tech. We're not even talking about totally optimized. We're talking about just not slow, right? Like I said, this compiler is not totally optimized. It's just not that slow. That's all. I'm going to make some tea, and then we'll think about what to do here next. Let's run some tests. What tea is it going to be? No, it's going to be hot cinnamon spice. Even the most basic lookup table highlighter runs at 200 megabytes per second. Yep. I mean, it like, how long does it take my compiler to compile the entire file, right? Syntax highlighting is a small subset of compilation. You should be able to do it way, way faster. Way faster. Way faster than compiling. Okay, well, let's just check in. Not Sokoban, compiler. Now the thing is, we still had a circular dependencies problem. So we added some telemetries. Oh, there's a no check in there. Oh, because that's, okay, hold on. That's literally what we were just doing. So we decided this was okay. Telemetries, okay. This is fine. So we were getting a circular dependencies error. And I just kind of want to run for a long time. See how often we get it. Maybe it's gone because we magically solved it. 1, 2, 3. Like, I feel like we were getting it at least 1 out of 10 times. Okay. That's like 4, 5. X prize for making everyday tech and software more optimized. Optimized is the wrong word, though. Like, again, optimized is not even what we're talking about. We're talking about not embarrassingly badly designed. It's a very low bar. Circular dependencies being impossible is the one good thing about header file hell. I don't know if that's worth it. I'm not seeing this problem happen, so maybe we fix it. Lol. I feel like we didn't really, but we'll see. We'll see if it comes up. So what do I do? Do I fix the spread operator implementation, which is not that important? But definitely cleans up something that's a little bit messy. Or I'm not actually sure what's the best way to do. There's like little nuances of how to do that that are maybe different. I think if it's like a no-op, so we could do, so spread operator is one thing we could do. The other thing we could do is start working on trying to get rid of that frickin' hash table problem. Where we're taking 30 milliseconds to resize a hash table. Is there a newbie-friendly video on compilers too? Not really. Like, it's a little bit different. Sometimes it's the semantics of the, it's usually multiple things, right? So sometimes it's the semantics of the language. So languages like Swift and Rust actually have type inference rules that are very slow. Swift is probably worse than Rust in that regard, but they're just inherently slow, right? So that's one factor. Another factor is that all these people who write compilers think that they know how to write fast code, but they totally don't, right? So that's like another issue. There's like an echo chamber about people thinking that they make fast code and getting mutual validation from each other that they all make fast code when in fact their code is very slow. Trying to explain that would, I don't know. It's hard to say something that really that really is meaningful for the majority of cases, right? So let me at least think about, I want to do the spread thing because it's little, but let's think about the message exporter thing. So basically we need to know when something is already hashed. And like, it's weird because, or not when it's already hashed, but when it's already been sent. It's weird that we do. Oh, we can't do a find and add. Right, okay, I understand. Okay, so we've got this hash table. It gets very large. Some people might have seen the stream a long time ago. It was a few weeks ago probably, where I was like, okay, let's try to reduce the size of this table because I feel like we don't really need it to be as big as it is. And in fact, it was very hard to reduce the size. That surprised me. Definitely surprised me. So the question is, I could make an array on the flattened for all of these things. And then you could just get it that way and it wouldn't use the table. Let's see. So supposedly let's just see if this assert goes off and how much. Right? If this assert never goes off, we're magical and golden. I feel like it will, but maybe it won't go off too badly. It went off. Let's see what it went off on. Is it something created at startup? Oh, it's a block. Oh, it's a block. But blocks don't have a type. Okay, so all right, we're just going to keep running it, seeing what happens. It's a declaration. Okay, this is a using thing that's imported. So I guess when we generate these, we don't like actually put them somewhere. I actually wonder if we should change the representation of these at some point, because we use a whole declaration for them, but it's really like a link that has basically no properties. And if we made it a separate thing, would that affect? No, we would still. Shh, 2015 comment, guys. Let's just enumerate all the times. We're just going to make a little learning experience here. That's all. Wait, what is this export hash minification? Oh, yeah. Those were the notes we made probably during that stream. All right. Anyway. So we're going to say handled equals true, bool handled equals false, and we're going to say if not handled, we assert that. All right. Else if ask type is ask declaration. Okay, so we're just checking that. Okay. Just going to keep going and see what all the different kinds of things are. Just going to make an easy breakpoint. Easy breakpoint. Okay, what is it? It's a struct. Line 78. Wait, why is it not? It's like its own expression. When we flatten a struct, do we not? Wait, this is not ensured flattened. It's in the infer pipe. Oh. Okay. Right. We're doing this check in a little bit the wrong place. For the information we're trying to find, because the thing is, here we check for exactly this case. Wait, why is this? What? This is confusing. Oh, I guess I get it. Am I not also using LLVM? I'm tired of answering questions about LLVM. We try to minimize the amount to which we use LLVM, and the long-term plan is to not use it at all because it causes too many problems. It's a problem. We don't like LLVM, except it does perform a decent amount of functionality that it's good that we didn't have to do yet, but it doesn't do it well enough for us to adopt it long term. Like, for example, some of the assembly language stuff we're doing is already running into LLVM problems. Okay, so the reason I'm trying to put this check where I am putting it, excuse me, is because that's where we just try to currently just read the hash table, right? But the reason we're reading the hash table before checking all this stuff is because that's fast and easy, supposedly. Although we know it's not fast because, as you know, we're spending time on it. So So this add deferred pointer here is what we would be doing. I don't understand this filtered out thing right now. This is weird. I don't get it. Is there already a giant fact page? There's a wiki that let me look on the secret Discord. There's a wiki link. I don't know if it's publicly readable. Let's see. Okay, you can go here. And it has relatively accurate stuff that the beta people are doing. I mean, relatively accurate because you assume, like, hey, look, they have access to the beta, so they are actually have experience using the language, unlike other things you could find on the internet. Like, it seems like a lot of this is covered in the how-tos with the compiler as well. But of course, you don't have that necessarily. Yeah, we actually don't really have documentation for polymorphism in the how-to, so it's good that there's something here. But yeah, there's a lot of info here. There's some info there that you could look at. Okay. Okay. So the question that I have here is, whoops, this is wrong. Haha. Okay. Let's just delete that comment. That's obvious at this point. It was maybe confusing at some point, but you definitely want to export stuff. Okay. So for the thing that I'm doing, I guess I could do this. We're going to say so let's just see what happens there. It's not called sourceexp here. All right. A literal, oh yeah, when we make literals, what a pain. Okay, guys, I need to think about some stuff. I really don't know what to do about this. Tomorrow's attempted stream is going to be all about trying to rearrange the memory storage of the way we do things. All right. And my presumption was, hey, when we parse things, right, we just have them in some kind of format where they each have an index into whatever, a particular array of things. Those array of things is probably going to be this flattened array, or that's where we're going to store the processed information, and then things will go around just being shuttled around in these flattened arrays, and it's all good. The problem is we all the time just make little one-off crap dudes, like, for example, when you cast a literal to something else, we just make a new literal for it. And when we make that one-off crap dude, where does he live? we could make like a little solo flattened array for that guy, but that's not very good. Or like when we make an implicit cast, when we're doing type checking, we make implicit casts all the time. So it seems very inefficient to pretend like this one thing that we make is, like a big array of stuff. Now we could take other approaches, like for example, we could have like this is just the array into which we put all the new things, right? And then when we're done, we sort of kick that off. And then other people could use it. I guess maybe that could work. The problem is it'll be confusing when we're in type checking, because we're going to try to store people's type in indices parallel with this array. And if we're adding slots to it all the time, that's no good. I mean, it's not that it's no good. It'll just be confusing because, like, we add a new thing in there. Either we have to, like, reallocate and expand the thing, or we have to be lazy and wait till code wants to read it, and then that's error-prone and full of if statements. Or we have a maximum size, right? And then that's just already allocated, and then we have lots of internal fragmentation from lots of these things being less than the maximum size. And then we have to deal with, or maybe it's a fixed size, and then when stuff goes through, you just maybe issue more than one. That's actually a possibility. Actually a possibility of it being a fixed size. But then we still have lots of internal fragmentation. So I am not sure how to deal with this. I could message Casey about this and see if he wants to have a talk about it tomorrow. I am texting Casey right now to see if he wants to do something tomorrow. Any plans for when I'm going to start tomorrow? No. It's sort of when I get up. Like, I don't want to set an alarm because I want to have high sleep quality because I think that that's important to doing good work. Right? That said, I don't want to start too late in the day because, like, then it's not an all-day stream or anything, you know? So, I don't know. My guess would be maybe we'll start at like 9:30 a.m. California time. Something like that. But that's literally just a guess. That is not a promise. We hope some value is happening tomorrow. However, it is quite possible that tomorrow will be a complete disaster where value will be value will be may prove elusive. But the goal is just to attack the problem. Value has been robbed from the people. No, it hasn't. Fake news. Fake news. I mean, maybe that'll happen, but it hasn't happened yet. It hasn't happened yet. Like the resolve type. Okay, so anyway, I don't think there's too much use in continuing on with this particular with this particular thing. Because we get what the problem is here. We get it. V gets it. V gets. V gets. So maybe the thing to do is just to do the spread thing while I wait to hear if Casey maybe wants to do this discussion. So let me just see what he has to say. He may have no interest in doing this because he doesn't really do compilers very much. But I think like this is more about multi-threading really than compilers. It's more about general multi-threaded data structures. We'll see what he says. Anyway, so back here, okay. I don't think we checked in this fix. Oh, we did. Never mind. Never mind. Okay. So it's not exactly about reducing memory usage. It's just more about reorganizing memory usage. Reorganizing memory usage. Is memory organization the last big feature for open beta-ness? No, it's not related. Like, I don't think this is on the roadmap to whether or not we open beta the compiler. It is, however, a relatively big, not totally resolved question that should get resolved, right? Because it does have an impact on a lot of other things. And so the sooner that we know what we want to do there, the better. Seems like he maybe wants to do it. I don't know. We're still back and forthing. Yeah. Okay, so let's just do the let me write some notes. Okay, so there's like the problem that we ran into here was flattened natural, but leaves orphans, right? So blocks per thread, but then related through entire compiler. Okay. Just writing down things that we would talk about. Okay. Oh, yeah. And then this thing. Expensive. Would that be expensive and bloated? Right? Implicit casts, substitutions, and so forth. Substitutions makes it maybe better to have a separate thing, ? Okay, we'll see. I have different ideas how to do it. All seem messy and non-ideal. So external feedback would be useful. Okay. Or rather, have a lot of fragments of ideas of how to do it, but they don't totally assemble into a coherent picture because of said non-idealness. Okay, cool. I am streaming now. Well, it looks like we're going to have a surprise call from Casey in about a minute or so, and we'll talk about this. Okay. I make sure my Steam is running, and I am Steam callable. Okay, he says in 15 minutes. Gradient convergence. Is this a stream? I guess it's a stream. It already happened. Oh, 23rd to 27th. Wait, it's an expo. It's a stream for an expo that's for 4 days. Okay, I get it. I get it. Minecraft Dungeons. Okay. The Isle of Dragon Roars. What is this? It's like a weird, cute dinosaur friend who likes treasure chests. Like, these two art styles don't really seem to go together. Yeah, so Casey says he's going to call at 9, and we will discuss. Sega Discovery Sale. Spike Chunsoft. Phantom Abyss Invasion Update. Publisher Sale. Corvs. Pre-purchase. Actraiser Renaissance. That's very hard to read. Very hard to read. What are all these? There's so many games, everybody. Medieval Dynasty. Sable with art by not Mobius. Maybe it is by Mobius. He's still around, right? Okay, that's very weird that you can like drag the image. Okay, did it close that window because I dragged the image? I don't know what happened. He died? Oh, that's too bad. Oh yeah, I remember that now. I remember that, I think. Oh, dude, Breath Edge is probably pretty big. We could get some space back from there. We haven't played this in a long time. An update and add-on. March 19. They increased the handy scrapper duration. Wait, did I play after this? Okay, so the really annoying durabilities are slightly improved. These are all things that take zero development effort. Filtering system. I don't even remember that. All right. So they're not really actively developing. It's been 6 months since they posted anything. Forgotten City. I mean, I forgot about it. Forgotten City, 9 out of 10 IG. Have some self-respect. A narrative-driven time loop adventure in ancient Rome. I mean, is this actually good? People are telling me it's good in chat here, but I don't know what that means. Is this actually good? Outstanding writing and performances? I'm going to hate it. Are you kidding me? What? They have no self-respect. And it's about story-driven performances, so I'm probably not going to like it, guys. It's cool if you like Outer Wilds. What does it have? Besides the fact that it resets, it seems like a totally different game, right? You keep items across loops. This is like the year of time loop games. It's very sad. Very sad. Uninstall Intel Bloat Pack. Yeah, it's true. I don't want, like, if I do that, even if I reinstall VTune, it like might not actually work. So since we had VTune working, let's not push it. Let's not push it. I mean, this game sold a bunch of copies, probably. Okay. We're just chilling for a couple minutes till it's discussed with Casey time. Anything else? Any questions that people have? Any questions? Any questions, people? While we just chilling. Memory changes for parallel processing. Yeah, among other things. Also just cleanliness of understanding the compiler, right? So let me write down. I'm going to warm up some more, this time not caffeine-free tea. Was there a reason for if-x? Because I don't like ternary operator syntax. I don't find it to be very readable. And when you have an if-x kind of thing, you could put multiple statements in the blocks, which you can't do with the so-called ternary operator syntax. Like the ternary operator is just, that's just a weird piece of C syntax that they made up, right? If our goal was to be maximally portable with C, or maximally like C, then we would do that. But that's not even a goal at all of this language. So yeah. No real outer wild successors. Yeah, I think it takes people a long time to clone games these days, so I think that'll happen. Just maybe not for a while. Let's make sure we use interfaces. I don't know what interfaces are in Java, and so, yeah, I can't comment. Interfaces are like traits. Everyone uses the same keyword for different things. I don't know what traits mean. Every programming language uses the word traits to mean something different. And it's like the most generic, or not even, it's the most abstract, meaningless English word that, like, it just turns my brain. Every time I hear the word traits, my brain shuts off. Like, I don't. Is there currently a way to break in the code and debug it during that time? Yeah. There's like an instruction by instruction bytecode debugger that you can break into. It's not like totally ideal, but it's useful. What about object? I know what an object is. I don't know what a trait is. I know what a reference is. I don't know what a trait is. A reference is just a pointer. That's easy. A trait, I have no idea what that is. Because a trait doesn't correspond to anything instantiated at runtime, right? Why call it a reference then? Because they want to pretend it's not a pointer. And actually, if you put on your smarty person programming language hat, the word reference actually predates the word pointer in compiler history. Like, pass by reference is an idea of how you pass values to functions that goes back to like the 60s or something, or 50s. I don't even know. Okay, we have a Casey call. Hello.
Hello, John. How you doing?
I'm good. I don't know. I don't know how I'll be tomorrow, but we'll see.
How you don't know how you'll be tomorrow? Meaning for the big reorg.
Yes, the corporate reorg, where we're going to be sending profitability to new heights.
Okay.
Yes, so we are streaming right now, by the way, just so you know.
Yes. Let me see. I don't actually know how I was gonna say how to see your screen. Should I just go to Twitch, or do you want to try and share it to me somehow?
If you go to Twitch, it'll have a little bit of latency, but I don't think it'll be that bad, right?
Okay.
And you'll just see what everybody sees, and that'll be easy.
Okay.
I mean, unless we find that doesn't work very well.
I'm doing it now. Twitch.tv/J_blow, right?
Somebody preemptively told me that your decibels are good, which is good. Nobody is saying I can't hear.
Oh, you know what I do have to do, though?
What?
I will have to sign in, because this is a subscriber stream, so...
No, you should... oh, right.
No,
like
no,
you're a mod on my stream, right? Yeah.
Yes, I am well within my rights to view the stream.
Yes.
It's just Twitch doesn't know that, so hold on a second, I don't want to...
You have to say, "Dear Twitch, do you know who I am?"
Yes, exactly. All right, so let me see if I can sign in here in some useful way.
If it doesn't work out, I can find a way to share the stream. It's just, I feel like once you've got OBS running, it's all over. Or maybe that's just for camera.
I don't think you have to do that at all. I just have to take a second, go look up how to log in, because I haven't logged into Twitch in a long, long time. But I will do it now. Okay. You can go back to whatever you were doing, and I will...
I was just hanging out with the people here. So...
You mean providing value?
Well...
For the people?
There are different kinds of value, right?
Okay.
And this is the subtle kind of value where you can't exactly see what the value is.
Okay. It's the intangibles, is what you're saying.
Yes. I'm transmitting the corporate culture to the people.
You're getting buy-in, important consensus building.
Yes.
Okay. All right. I think that worked okay. So let's see here if I can get the stream up. Twitch has to send me a verification code.
Well, good.
So. And okay. Yeah, so that looks right. Okay. So let me go ahead and get myself situated here, and then I think I'm good to go. Okay. I have no idea what we're doing here other than what you just quickly told me, by the way.
Yeah,
so
I can do an intro
don't know
right now.
What you've been looking at, but
as soon as I finish munching on peanut butter M&Ms, I will intro.
Okay.
Okay. Back when I started writing this compiler,
Mm-hmm.
you know, I've done a bunch of programming languages. This is way more serious than most of them, right? But I kind of know how compilers go, right?
Okay.
And so when I did it in the beginning, I did it in the way that almost everybody has always done it for decades, right? Which is like, okay, first you have to parse the thing out of the file, right? And we actually had another stream about parsing that maybe people in the chat have seen.
Yep.
Right. But the way you typically parse things out of a file into a programming language, if you went to computer school, is like, you know, you start looking at the first characters, and that gives you some idea of what you're parsing. And then once you really know what the next thing is, you like make a tree node for that thing, right? Mm-hmm. And then you sort of recurse or something, right? Maybe if you're using one of these stack machine thingies, it's not exactly recursing, but you proceed onward, right? And the reason a tree structure is natural for parsing a programming language is Well, stuff like math operations or whatever are binary operators. So you have some information about what the operator is, and then it's like, well, what's on the left side and what's on the right side of the operator? And sort of the general expressive power of a programming language comes from the fact that it could be just about anything in the language on either side there, right? That's like what gives the programmer a lot of flexibility. So like if you only had room for like an 8-bit integer on one side of that or something, that would be very restrictive in terms of what people could put in, right? So
Yes.
so that's all very unsurprising, right? This is like how everything works. And then as I went on to build the rest of the stages of the compiler, which all happened very quickly, actually, right? Like I had the first version of it with all the compile time execution and everything in like 6 weeks or something.
Yes.
But and by the way, chat, that is the difference between a cool demo and like a production quality thing, is that it's now 7 years later and we still haven't released the production quality thing. Okay, well, what are the other stages? Well, okay, you've parsed the thing, but you don't know what the types of the things are, right? You haven't looked up the names of the variables, and depending on if that variable is like a string or an integer or whatever, then if you're building a function call, say, right, then the slots of the arguments of that function call, they need to have different types that you know what they are, so you can like type check it and all that stuff, right? Mm-hmm. And then, of course, at various stages of a compiler, there's just temporary scratch space you might need. So like in this language especially, calling functions is like fraught with peril because there's generics, there's overloading, and there's nonlinear compilation. So in the middle of doing anything, we might have to pause and come back later, like without, like while correctly not recomputing things that we already computed and whatever, so that things don't go slow, right? And so there's just a certain amount of state that we keep for each of these, or especially for the more complicated nodes, right? And the way that I did that starting in the beginning is I just put it on the node itself, because I was like, look, I don't want to fall into this trap that the so-called computer science academic people do, which is they just love having like billions of redundant representations for their program and like translating back and forth between them. And so like instead of, okay, so one very simple example is just the type. Every node in the program, in the tree, whether, binary operator, a literal, a unary operator, a procedure call, it has a type assigned to it, right? And this is just how most programming languages work. And the way that we compute that type is there's just, for every unique type that is ever constructed, that's got a node, right? It's called a type definition node. And then we just point to that from the syntax tree node of the thing, right? There's just a slot.
And that could be like a compound thing.
It itself,
like
it could be like a
something.
Pointer to another type, for example, right? Or it could be a struct type or whatever, right? So yeah. And that's, again, why it's a pointer to a thing, is because the thing could be really complex, right?
Right.
Okay, so there's just a slot on, there's sort of a base node that's got a bunch of stuff that everybody has, right? So for example, position in the source code is one of the things in there.
Right.
For when you do error message, right?
Yeah.
Just flags that we use for various reasons. There's just a certain amount of bookkeeping that we have, and some of it maybe we'll talk about later because it's some of the things that would be better stored in a different way. But so the it's called the inferred type slot goes on that node, and then every one of these specific kinds of nodes has all these bookkeeping things on them, right?
Okay.
Okay. This has a couple of problems, which I hinted at through the text messages, but we'll cover them for the people, right? The earliest problem we had is that it's just kind of hard to understand. This is maybe fixable through commenting and stuff, but if you go look at these syntax tree nodes and you're like the summer intern, right?
Yeah.
You have no idea which of them are meaningful at what time, right? When in fact, usually what happens is they're initialized at some stage of compilation and valid thereafter. So I could go through and like comment that, right? But it's sort of a thing where like it's a little bit messy that there's a lot of this information that's laying around, or potential. Like just a lot of like things that kind of are taking up memory and often don't do anything, right?
Okay.
So the second thing is a lot of this information is temporary in nature. A lot of it isn't. Okay, so here's the thing that's weird, and maybe why the second point isn't as important. Because we give so much information to the user level program, like your meta program that's running, like we give you the whole syntax tree and all this stuff, and that's in a whole separate format, right? Because the system that we give you, or the data structure that we give you representing the program, has to be like stable and not at the whim of like internal changes in the compiler, right? So we actually export all this data, and that actually has to stick around, right? So like at some point, the amount of memory that we get rid of might actually be relatively small fraction, and it's not worth thinking about. But that's, but at least in principle, if we need certain temporary structures to like resolve a procedure call to figure out exactly what it is and do all this like yielding and recovery and stuff for the nonlinear compilation, then after that's done, we don't need most of that anymore, right? And if it's just part of the static type, like there's a procedure call, I forgot you could see my screen, right? So there's this procedure call node, which is like, I to my chagrin, I use C++ subclassing for exactly two things in the universe. One of them is entities and one of them is nodes here. So this is it's just very strict single inheritance. And all this is doing is exactly the same thing you would do in C for the people out there who do C, where you just put the struct at the beginning, right? Except that you get a little bit of like extra type checking and stuff. So there's no methods on these ever, for example. They're just structs.
Got it.
So, and I guess there's this constructor because you can't actually assign to the thing. Like you can't assign to the type field that's in the base class without that or whatever. Okay, so, here's an example. Like a lot of these fields here on procedure call are just work things that are used later. Or initially. So this call resolution status is one of these things I was talking about that like, has some lifetime while we're doing type inference, right? Macro expansion record is like if this call actually was a macro call, then we go copy the body of the macro and like stick it here, and stuff like that. Which actually brings me to one disadvantage of doing things this way, of which there are several. Okay, actually, one of them was the memory use. Like, we can't really reclaim memory. One of them is it actually makes the compiler probably a little slower than it otherwise would be because, as it turns out, and I didn't know this in the beginning, but one of the features in this language that we use an awful lot are like the generics or polymorphics or whatever you want to call them, where, you can have a procedure with some compile time determined parameter, and you call that, and it generates different target procedures, right? Now, in principle, if you want to do that, generate a procedure, let's just say it takes one argument X, and you wanted to change the type of X and generate 5 versions of the procedure, right? In principle, you just take the syntax tree, and you just pass it to the type inference routine or whatever, right? But with a different parameter. Sounds easy, right? Of course, once details get gnarly, it's not that easy. But it's especially not that easy because we store the type on the node, right? So every time we do something like that, we have to copy the whole syntax tree of the thing, right? And make sure that nothing from later stages of compilation is accidentally initialized, right? And whatever. And that's a little bit of an error-prone, complicated process, but it also takes CPU time, right? Whereas if the data were factored apart, so I didn't mention this, but like there's stuff on this call that is essentially parsing only stuff. So like procedure expression here, that's just what did we do at parse time? Like what function are we? It's usually an identifier, but not always, right? Like you can evaluate a complex expression that returns a function pointer that you then call, which we probably do rarely, but we do it, and it's important, right? For the arguments you put in, we allow named arguments. So there's a couple of arrays here that like, let us do that and so forth. So, and by the way, I almost never use templates either, but I use them for arrays because
Right.
I would
Yeah,
go
I
crazy
gotcha.
without that. Um,
Okay.
okay, so that's one of the disadvantages is that it actually probably does cost us some CPU time and it does cost us some code complexity, right? Because if we had the data separate, we could
Yeah.
just say, just start, and not coincidentally, maybe that's also kind of the thing you want to do for threading, right? Is you want to know, okay, after we've generated this data, it's read only, and like you can do whatever you want with it, and you don't have to worry about it, right?
Yeah. Yeah.
Okay, so that's a thing.
Which also, I mean, like, depending on how you're actually doing the part where the user can operate on the AST, I could also imagine wanting to collapse those two things down. So it's basically like, look, once we create any AST tree, it is always there because we don't want to ever have to copy. So like, we just always write new ASTs out at the end of like our AST set, so that we don't have to think about like which threads and or the user are like pointing back at this thing and looking at it,
Yes. I
right?
mean, although, one discussion that we had previously was that like this compiler, it uses enough memory that like when Ryan was profiling it, like memory use was like 10% of the CPU time, like zeroing pages. So like we're not eager to use a lot more memory than we already do, right? That said, there's a lot of pointers here, right? So if we go to some other representation that uses indices instead of pointers, like maybe memory usage shrinks a lot. I don't know.
Well, yeah, I mean, there's a lot of stuff you could, in looking at this, as an example, it seems
Yeah.
like there's a lot of stuff you could do, right?
Yeah, and so I mean, there's plenty of stuff. It's just I want to make sure that if I start doing stuff, it's on a
Yeah,
coherent line toward
yeah,
because let's be very clear. Any data structure refactoring that I do here, it's going to be one of those ugly and painful things where it like just breaks stuff for a while, and it
yeah.
sucks, and nothing
Okay,
compiles, and then
okay,
eventually I have the same thing I had before, but with a different data structure, right? And those I haven't done one of those in a while. I have done a number of things like that in the history of this compiler. They're never fun, but after you've done
okay,
them, it's always like this thing is a lot better, right?
okay.
Like you just
Yeah,
have so I just want to make sure that if I line up things like that, right? So an obvious thing you could do, for example, is instead of having pointers to everything, right? You have your nodes. Like you could imagine that every time I allocate a node, it's just in some contiguous buffer, for example, and then I have byte
yeah,
offsets to all the nodes, and you use byte offsets. And if you assume that no procedure is going to use like more than 4 GB of byte offsets or something, then that fits into half the size of our current pointer, right? Because it's a
yeah,
32-bit integer, and then all the nodes shrink too, right? Just even if you store the same effective number of pointers or whatever, except right. It maybe is that simple during parsing. It's not that simple for like inference and stuff later on because you can point at things like, I don't know how far away in the program is something that I point at, right? And it was probably generated by a different thread and like all sorts of things like that. But, there's certainly lots of things that could be done of this nature, like everything that we parse, like if we're parsing a function, we're parsing that whole function in the same thread or whatever. It can be all contiguously and tightly packed, and like that's a natural thing to do in a sense, right? And to
well, I
use
also
that
wonder, I mean,
locality.
so not knowing very much about the structure of this particular program, the first thing I would ask myself is are these things really that different in size anyway? Like, can we not just say that there is a fixed size AST block that is the head block for each one of these things, and that way an AST pointer is always just the 32-bit index into an array of fixed sized AST blocks? Because there's not going to be 4 billion AST nodes in a program. I mean, unless they're the
Yeah.
LLM code base or the Unreal
Well,
Engine, maybe there is. But
I was talking to someone who worked at Google, and it was like, so it actually wasn't my question, but someone was asking, so like how many millions of lines of code do you think get built every time you rebuild? And she had no idea. She was like, I have no way to estimate that number.
I mean, yeah, I think unless you were someone who was literally tasked with investigating such a question at one of these companies, the answer is just like too many.
Yeah.
I don't know the exact number, but it's very large.
Yeah. Okay. So stuff like that is a possibility, right? Again, I'm not eager to
before
use
we get
more
into
memory.
that, I need to know one thing.
Yeah.
Why is the operator overloading alternative knowledge token 1991? Because it's staring at me that I'm fascinated now.
This is a weird thing. This has drifted from where it's supposed to be, but this is an old method that I was experimenting with of making sure that things stay in sync across the code base. Mm-hmm. And I don't really do it anymore. Let me find a better example of this. So for example, the format of the string type in this language is it's got like the generic unpacked string type, right? It's got like an 8-bit count. And if I ever change any of these, right, I can change this. And there are places in the code that assert on this, right? So this is just a random number. And if I change it to like 3355, a bunch of assertions will go off and then I go do that, right? Now, the problem is this...
a way of getting like type checking on your constants, basically.
Yeah.
By forcing there to be sort of an error as best you can. You know.
Honestly, I think it's better probably to assert on the individual ones though, but I don't know. Like it just, I don't end up doing this very much.
I get it though.
Yeah. But
like
so you can see it should be pretty obvious, right?
Yes, that makes sense.
Okay. Anyway. So here's the thing is there are a few different groupings that are natural. And the problem is that I'm not sure that any of them necessarily works that well. So if I want to do things in a threaded way that involves data being packed together, I maybe have to make a new grouping that's just for threading. And okay, let's talk about a different issue for a second that might feed into this, right? Which is if I wanted to break this data up so that I have like parse data and then type inference data and then like byte code generation data and whatever, right? Yep. The most understandable thing and probably the most threadable thing and stuff is just like, look, you have separate arrays of each of those things. You have somehow an index for each syntax tree node, right?
Yep.
And that index lets you get the pointer somehow relatively quickly. Who knows what that is, but you have it somehow.
Yep.
And then like in the type checker, right? I have the inferred types that we were talking about. Instead of storing that pointer on the node, I just have an array of those, right? Hopefully the indices that I have are relatively dense. So I could just have a packed array of inferred types. They all start out null. And then the process of the type checker is to fill those in with non-null values, right? Mm-hmm. And so forth with various data through the compiler. The thing is, with some of this data, let's go to like binary operator. Like when we're generating, the thing is you want to be able to reference up and not just down in a sense, right? So like when I'm generating the code for the binary operator, I of course want to know the types of things, but I want to be able to like essentially go look in the left and look in the right and like get the types of those nodes, right? So like this starts to raise questions depending on how things are stored, right? Okay. So what if I generated these indices, for example, and there are reasons why this isn't a good idea that we'll get into, I think, but the laziest way, like I'm a big fan of doing things in a relatively lazy way that makes somewhat progress and keeping the system running and then later taking it one more step. So a lazy thing I could do is anytime in the base syntax tree node thing here, right? I could just add something that's like whatever index information that I need, right? And as I generate on a particular parse thread, I just, increment that or whatever. And that tells you not only where where this node is going to be in some memory arena, right? But it also, that's the index that everybody else uses. And then the thing that kind of, how would I say it? So when I'm later doing type inference and I have an index to that node, I can go see what the indices of the left and right node are by getting the pointer to that index of the operator, and then looking at its left and right index or pointer, depending on what's there, right? And then getting that value and then coming back up. But the problem is I'm kind of like, while I'm doing code generation, I'm kind of going back to parse tree nodes and navigating around them, which maybe has bad memory performance properties, right? An alternative that I could do is, you could imagine instead, for every node type, like if I was in computer science school and I wanted to like factor this tree apart, right?
I liked it better when you called it computer school.
Computer school, yeah. Sorry, I said science. I didn't mean to. If I'm in computer school and I want to factor my tree apart, let's even just say I do a super simple factoring where we break it into two trees. One tree has the read-only data that you get from parsing, right? And the other tree has everything else that's generated through the rest of the program, right? You could do that, and that would solve certain problems. Like I wouldn't have to copy the read-only part. We could generate, it doesn't really help you with threading and stuff, I don't think, or the organizational problem. But one downside of that is that now you probably have redundant representations of everything. So it's like maybe in the, like I would have asked binary and then, I don't know, gen binary for generated information or something. And gen binary would have like maybe a pointer back to the syntax tree version, right? Who knows? Maybe this is stored as an index, whatever, but logically it's a pointer, right? Mm-hmm. But then the problem is, if you just go to this syntax tree node and you look at the left and right pointers, that doesn't get you back up to this information, right? So you could do this thing where you're like, okay, gen, expression, left, right, and right. And then each of those points down. But this is very inefficient memory-wise, right?
Well, I mean, again, this depends on what you mean by index, right? So, you know, one of the reasons that I'm not a huge fan of byte indexes, because you were talking about byte indexes, right? There's two reasons not to like byte indexes. One is because it's very hard to work with byte indexes if you ever want to delete anything or reuse space, because you're talking about general purpose allocation at that point, where you've got, you know, when you remove something, you've got a whole of a variable size, and that's fine. And I don't know that that's a huge issue for this kind of code base. But the second reason I really don't like byte indexes is potentially very relevant here, and that is that they only work in one direction. So a byte index gets you, it's a mapping from the index to the type, but it is not a mapping to anything else, and that's very like underpowered. So to give you a simple example of what I mean, suppose that you just had your ASTs were just indexed. So it's just 0, 1, 2, 3, 4, 5, right? Mm-hmm. So, and if they're all fixed size, like we just pick a size for these ASTs and everything gets packed into that size. And if you want more than that, you're in some additional spillover space or something, right?
Yeah.
At that point, that index, you can choose to isolate things that everyone wants to know about node 7, right? And put those in, and then later, if you're talking about, you're looking at something you generated, you will know at that point that if you just generate the thing that was supposed to be generated for node 7 in slot 7 of the generated array as well, they both correspond to each other automatically.
Oh, totally. Right? Yeah. Yes.
So I do feel like there, you know, since I don't know this particular code base at all, I can't say that that's helpful, but like thinking about things like that, where it's like, oh, okay, what portion of these things could we solve by lining up a convenient index across multiple tables was just something that jumped out.
What I would say is that that's kind of what I'm trying to get at, is that I'm trying to do something like that. Okay. It's just not that obvious how to do it.
No, not in something this, you know, ASTs are very hairy, right? They're pointing
Yeah.
all over the place, and so it's kind of hard sometimes to untangle.
Okay, but so there's sort of two natural places that a grouping like that could happen, where you could assign indices to things, and one of them is, at parse time, right? So,
Hmm.
because you're just allocating the nodes in some order, and it's roughly the order that you're going to traverse them later, sort of,
Hmm.
probably, maybe not actually.
There's at least
But
locality to it. Like they're
yes,
not arbitrary.
so it's like not that bad. Um, the problem with that is, um, in general, in a programming language like this, especially a more modern one, like the thing that you parse is not necessarily the thing that you generate code on for various reasons, right?
Yeah, especially not if there's metaprogramming. Obviously, you've got
Yeah.
multiple stages as well, so there's not even a single generation.
Well, metaprogramming stuff is a little bit of a heavier tool that I'm going to talk about now, and so
Okay.
I put that in a different category. But
All right.
like so every programming language has stuff like, oh, we support this syntax, but it desugars into this other thing or whatever, right?
Hmm.
And so you see that thing, you generate some replacement nodes for that thing that are this other thing. Now, we don't do that very much for the following reason. Because we are communicating heavily with your metaprogram and we want to give your metaprogram information about your
Right.
program that makes
Right,
sense,
yes.
you don't want to see something very different from what you wrote. Okay.
Right.
So
Yes.
we actually eschew most desugaring, but some does still happen. And usually when it happens, though, what we do is we do type inference and stuff on the desugared thing, but we can map that type pointer back to something coherent in your original thing, and we just give you that information, right? So in cases like that, we
Right.
allow ourselves to do it. But like some languages do rampant desugaring, because one of the academic things is like you should have the minimal possible semantic representation of your program or whatever in terms of, and like that's kind of true, but like if that leans heavily on efficiency or whatever, it's a bad idea, right?
Right.
Okay, so there's that. There's constant evaluation. So without even having to run any kind of meta program, there are guarantees that the language semantics give you about things that just are constant at compile time, right? So like if you add 3 plus 5 in an expression, that is not just guaranteed to be computed at compile time, but it's guaranteed to be treatable as a constant exactly as if you had written 8, right? And so that has guarantees, like you can bind that to a constant identifier that could only be used in other constant contexts, right?
Right. So if you have an array and you say like brackets 3 plus 8, it's not allowed to say I expected a constant here. It has
That's
to
right. It
evaluate
has
that,
to accept that.
see that it's 3 plus 5, which it can compute, and go, okay, 8 is a constant. I'll make the array.
Yes. And so because that happens, what then happens is, there's a data structure for a literal. I'll go show that to the people, right? It's actually pretty complicated because it's for all literal types. It's got this union of like what's stored in there and whatever. But so when we see 3 plus 5, you have a plus and 2 literals on each side, and we detect that situation and we make a new literal, right, for 8. But we don't overwrite the old literals because we need to send your metaprogram those old literals, right?
Yeah.
Because you want to see the 3 plus 5.
Right, because maybe you wanted to do something.
Yeah. Or I mean, maybe even you're just translating this to another programming language even or something, right? Or maybe you're generating the markup for your editor, right?
Yep.
So that you, whatever. Like we have to provide all that stuff. And so,
yeah, absolutely.
So after parse time, we actually generate a substantial number of things. So that's one class of thing. Another one is just like implicit casts, right? So we have a node for cast. And there's a few different kinds of casts, but like, okay, so I have a variable, it's an unsigned 8-bit number, and I assign it to something that's unsigned 16-bit that just fits. So we permit that assignment, right? And we invisibly generate a cast there. And your program actually gets this information. It's like there's a little bit of an interesting philosophical question about what actually goes into the tree given to your metaprogram and what doesn't. But things like implicit casts, like they seem important enough that you want to know about them. So we give you that information. It's not like a hidden desugaring. It's like an implicit thing that we add that you can see. But it's also marked as implicit, so you can tell the difference between one generated by the compiler and one that was typed by you, right? So a lot of these get created during compilation as well. And the problem is for later stages of the compiler, there's not really a practical difference between this kind of node and things that came from parsing. In fact, this is like the same node, it just the members are a little bit different, right? And so if we generate some of these, but the place that we generate indices for everything is parse time, now we have a bunch of things without a home. And what do you do? Well, maybe one strategy is the stupidest possible thing, which is you make little singleton collections for all these things that are very inefficient. But then you have this question about things pointing to different, like if things are packed into one array and then things are packed into another array and you're pointing across there, that's it takes more memory to do that, right? And it's more complicated.
I guess I'm not sure I understand the problem. Like, why don't they just go on to the end of the?
Because well, that's part two. Part two is you grow it somehow, right? Either you grow it dynamically, or you have a fixed maximum size, right? And you keep filling that up. And after you fill that, you generate a new chunk. Then you have to point across chunks again, right? But you could do that. The reason
I think I might be missing some thing that's going on here. So
yeah.
But why can't this array just keep growing? Like what's the?
Well, there's like a lot of them.
Now,
I mean, so this is the thing: is like if I felt like I knew that I could have an infinite number of these, then I guess I can do the virtual address space and just let them keep growing. I don't necessarily know that right now. I think that it depends on what the rest of the design looks like. But anyway, the other thing I wanted to get to is that for various other reasons, parsing is maybe not the right grouping. Although maybe it is, I don't know, maybe it is. But these are just the things that I'm thinking about, right? So if you did a growing virtual address thing where you just keep appending memory as you create these things, then I guess what that looks like depends on how the data is fact. I guess you would pretend like there were, or you would want a syntax tree node for everything, I guess, and you would still mark it as implicit, and you would append it to the existing ones, right?
Yeah.
I mean, I guess I'm hosed if we ever try to port this to like the Raspberry Pi or something, if we do that, right? Because like at that point, the design of the entire compiler assumes that we could do this, but maybe that's fine.
Well, I mean, yeah, like I guess my knowledge of exactly what VM stuff is available where is not fantastic, but does the Raspberry Pi not support this? I mean, it's a 64-bit processor.
I don't actually know. That was just a random guess, right? Like, who knows?
Well, we're kind of having this problem on WebAssembly right now, in fact.
Oh,
this is really annoying. The 64-bit address space thing is a huge problem because a lot of algorithms do get much more efficient if you assume that you have virtual address translation. And if you don't assume you have it, then you effectively throw away a huge amount of CPU horsepower that is built into your processor for doing it. And you will end up basically doing it yourself in software. Like you'll come up with some other scheme that, doesn't need that, right?
Yeah.
And so, yeah, you're always going through the virtual memory hardware, so you might as well use it, is usually my opinion. I can understand why someone might not want to rely on that, but at least if you're talking about the kinds of things that people generally compile stuff on,
yeah, maybe it's
I
fine.
would imagine.
Yeah, I mean, it's just scary because I've never done that before in something that where like, if it's like a side thing where you can have multiple implementations, it's like, okay, if this is ever a problem, I just write the slower implementation, right?
I mean, the slower implementation is just a hash table, right? And so
yeah, it's just if all data structures in my thing, I don't know. I mean, maybe it could be written such that it wouldn't require an entirely different source code to do the slow fallback. I don't know. I would have to assess that depending on what the thing looks like. So
yeah.
Anyway, okay. However, so the thing about all this is there's a different grouping of things that is maybe probably more natural.
Hmm.
And it's similar to the syntax tree grouping, but is not the same thing. And that is, okay, where is it? Okay. So,
Sleeping on me. I like sleeping on me.
oh, there's lots of sleeping on people. Don't worry about that. So there's this thing called the flattened fur infer and a thing called the queued. And what these are is,
You sound like Star Trek.
okay, because it's
The
queued.
queued and the
Queue is-
flattened fur infer. It's like, okay.
Okay. Anyway, the purpose of these things is, um, the way that things get compiled in this language is it's nonlinear, as you know, right? Like the job of the compiler is to
Right.
figure out the dependencies. And if I'm trying to
Right.
compile your function body, but we need something else to happen first, then, well, we just need to go do that and come back and finish your function later, right? And the way that that is all managed is through this queued structure here. And the reason it's called queued is just like there's some queue of like who's going to get type inference run on them or whatever. There's queues for different stages of the compiler actually, but the type check phase is the biggest, most complicated one. And this just has a bunch of data. And I really haven't focused on trying to reduce the number of things here, so whatever. But it's got a certain amount of data for what I sort of think of now as each compilation unit. It's not really analogous to C compilation units, right? Because they're a lot smaller. But the definition of compilation unit here is like anything that you might have to do out of order from other things in order to compile, right? So for example, if you have a function definition in your code, there's actually two of these because, just like in C, you have like the header and the body, and you don't need to see or understand the body in order to write a call that calls the header, right?
Right.
We do the same thing implementation wise, but it's just invisible, right? So we make one of these for the header and one of these for the body, and it's generally easier for the header to like pass through the system faster because it probably doesn't refer to nearly as much stuff, right? And so that's the thing that you need. So once the header is type checked, then you could call the function from somewhere else, right? And then the body eventually makes it through. And in fact, the body waits on the header because the body isn't going to know what the argument types are and stuff until the header's done, right?
Yeah.
But of course, the header might have to wait on other stuff arbitrarily long before you could figure it out, right? Okay. So I have to iconify chat because people are asking me irrelevant questions and it's breaking my concentration.
Okay.
Welcome even to subscriber only stream. So what was I even talking about? Oh yeah. So
You were
explaining this
about to
basic
say,
thing.
I assume that this has implications for how you would like to enumerate things.
Well, okay. So the way this gets filled out initially is we do a walk over. Well, okay. There's some piece of code that decides at a top level what is a root of one of these compilation units and what isn't, right? So like if you see a function, it's always separate, right? In the body of the function, like the different statements don't really need to be handled out of order because the definition of the body of a function is that it's like it's one thing after another, right? So it's not like you could refer to things in the future in the body of a function usually, except I do let you do that a little bit if there's like another constant function declared in the scope of that function because you're supposed to just be able to paste function definitions around, right? So there's a little bit of nonlinearity.
And you can go to like C has that too. Like you can go to a label that hasn't been seen yet.
Yeah, we actually don't do go to yet, but
well, I'm just saying like that's not that like
that would be a similar issue.
Languages do kind of have that problem of like, well, once in a while in a function body you can kind of talk about something that hasn't been seen yet.
Absolutely, yes, and you kind of have to, or your language is a little too limited.
I'm sure it's always everything always has a little bit like that.
Yeah, I mean maybe if you go way far back in time, right? They didn't do that because it was too scary, but like yeah. Okay, so. In general, like separate statements in data scopes, like if you have a bunch of variable declarations in a data scope, like the global data, those are all, each one of those declarations is a separate one of these queues
Right.
because,
Yep.
you know,
Yeah. You don't know what order they need to get untwined.
no, they could refer
right.
to each other. Other people could, whatever.
Yep.
But inside the body of a procedure, if they're stack declarations, we don't make separate ones because that's more inefficient and et cetera, right? Okay. So the stuff travels through the compiler in this grouping, right? And the way this works is, and this is actually something that's one of the things that makes this confusing to think about is every time I talk about a subsystem, there's like the way it is now and then the way it probably kind of should be, right?
Mm-hmm.
So the way it is now is when...
So it's like caterpillar and butterfly.
Yeah, except you never quite get to butterfly, really.
No, you're just always in the chrysalis.
It's like you're a half butterfly, but the other wing is still stuck as
Yes.
as maggot or something.
Yep.
Yeah.
Yep.
So anyway, so what happens is we have this thing called the flatten process, which I did this way because it's the absolute stupidest thing. It's very easy to debug. And the way it goes is as follows. We decide something should be a queued separate compilation unit. We start recursing down from the root in what is known to be dependency order, right? So if you're going to do a plus operator, right, then you need to know the types of the left and right sides of the plus. And then you can do the type of the root of the plus, right? Now, the left and right don't really matter, but like it's fine. You can do them in arbitrary order, right? So, so what we do is we say we put the pointer to the expression for the left, and then the pointer to the expression for the right, and then the pointer for the root of the plus. And this process of inferring a body of a function, for example, or any compilation unit is we just start at index 0, and we start going linearly across this flattened array. And if we ever have a problem where like you're using a variable that we don't know what type it is yet because it's like referring to something far away and it's not ready, it's very easy to pause that and come back later because we just have the index of where we were, right? And you just restart from that index and you go down to the rest of the array. Now, the thing that's not good about that is like it takes CPU and memory to do that flattening. It's not that bad right now. And the benefit is that it's easy to debug. But the thing that's bad about it is it's like, okay, we recurse and visit all these nodes. So we pay that cache price, the random access, random-ish, local-ish access price to navigate this whole tree to like flatten this thing. And then we go do the whole thing again because we're going to inspect all those nodes from left and right again to do the type inference, right? So it's 2 passes when it probably should be 1 pass, actually. Like when you go to infer a particular node, maybe the state machine for each node is much more complicated about how to know how to resume, or maybe we just have a very temporary, much smaller flattened buffer, right? Where if you go do plus, maybe we push left and right and then top in like reverse order, right? Because you're going to go to the left and maybe push some more stuff, but it only grows as high as it needs, you know, for what you're inferring at the time and stays mostly local, as opposed to, you know, the whole frickin' function or whatever, right?
So does that imply, though, if I'm understanding correctly, that effectively, I guess what I'm trying to understand is how much information does this flattener have? So is this flattener able to run basically just on the parse alone with no...
It has a little bit more information, like, well, okay. This
I
is
guess the first time it has to, right? At least the first person the first time you flatten something, it's going to have to just be what comes in off the parse because you don't have anything else to start with. So
yeah, well, and in fact,
right?
In order to remain sane, you actually don't want it to depend on any other. Well, okay. The way it works is flatten only happens once. It happens on information after parse time and before type check time, right? It's necessary in order to do a type check on things. If we go do some polymorphism thing later where we recompile various portions of a function, the job of the copying that I mentioned at the beginning of that function is essentially to generate an equivalent to parser output, right? So if you copy it, it gets reflattened later separately, right? From the thing that you copied. And the flatten process looks like this, where for each type of node, you just do this. C macro just says put the pointer, recurse into this node, and put the pointers in the order that node wants to, right?
Yes.
And so there's some macros here to make it short, because most of the time what you want to do is recurse into pointers or whatever. Now, based on the contents of these things, sometimes we need to do different things, but it's never like, we don't know the type of anything at this point, and we're not allowed to know. So, yeah.
Can I ask a question at this point?
Yeah.
So, would it be fair to say, I'm going to describe a system for just this first part that we're talking about. I would like to describe a system and have you tell me whether it would actually be a replacement for what you currently have, or whether I'm missing something.
Okay.
And I'm not claiming I can implement this system. It's sort of like a pie in the sky statement, but I just want to see if I've got the idea right.
Yeah.
So the actual flattened, the data that's in the flattened portion, like after I run flatten and I have the output of flatten.
Yeah.
The indices in flatten, so that array that has like, here are the AST nodes in the order in which I believe you have to type check them.
Yeah.
Is that effectively a like postfix notation? Is that just basically like a reverse Polish notation calculator? It's basically just, we could run that and literally have the output of the program, because it's like push A, push B plus, push C plus, right? Function call.
I would say it's analogous to that, yes. There might be some implementation details that make it a little bit more gnarly, but that's kind of the basic idea.
Because it seems to me that sort of does. I feel like maybe I'm hopefully confirming what your suspicion was, because I'm also thinking it, which is that does seem like a very natural place to start then, because it sort of suggests that a lot of the compilation could be done just with that way of thinking about the data. Because it is not only is it the thing you actually want to do your type checking, but it's also the thing that you would want for like code gen. It's also in the order that you would have to visit things to generate the code for the thing.
Yeah, possibly. It's interesting because I don't use it for code gen. When I go to code gen, I just go top down from the root, but it's quite possible that would work. The question is if I actually need a different flattened order for code gen, because the problem is, during type checking is when we often will expand things to sub-expressions and insert new stuff and whatever, right? And actually those do all get flattened, but they get flattened into like different substructures. I don't know. Like, it is quite possible that could be a design that we would do, is we would, well, let me throw one more thing in there, right? Which may elaborate on this idea a little bit. So the idea originally was, this is just sort of a dependency thing, right? Like, before I can do my thing, I need these other things, right? But for some nodes, it's a little bit more complicated than that. And you kind of want to stop in the middle and figure something out, right? And then do some more. Or you want to say, well, there are certain times. So for example, if you're saying like size of in C, right? Whatever's inside the size of is not really a thing that you're like really evaluating, right? It's not going to run. It's just like, I want to know the size of this thing. If I type this expression, how big would it be, right? And if that expression is arbitrarily complicated, like it could be weird in the code for you to know whether you're talking about something real or not and what you have to do. And in a language like C that just goes in a single pass, it's maybe not that complicated, But here, where it's very nonlinear, it is complicated. And so we do things like, well, we need to do things like, well, let's actually push a little variable that says that what we're talking about now isn't totally real, and we'll pop that later, right? And so this thing evolved into something that isn't totally dependencies. It's actually a little bit of a command buffer in some cases now. And so if you look at
very much, yes,
if you look at this procedure call thing here, right? What happens is first we go this procedure expression thing. That just means, hey, recurse down into there and do all this stuff for whatever arbitrarily complicated expression that is. Then we have a certain expression called procedure of call, which is a way of dealing with overloading and stuff, which is like, it's kind of like size of in the following way. It's like, I'm going to write a function call just like I would write if I was actually calling the function, but I'm going to mark it with this directive. And the directive means don't call the function, just give me the pointer of like whatever that function would have been, right? Mm-hmm. So like do all the overload resolution and stuff and just give me what the thing is, right? So it looks exactly like a function call. We need to do all the type resolution in exactly the same way, but there are like some things that are legal in that case that aren't legal otherwise that I forget exactly what they are. But that's why, so here we're making a new utility node, which is in the same syntax tree hierarchy, because that's just the hierarchy everything's in. Who knows, like maybe it should be a different thing. But we're making a node and we're adding it to this sequence, right? As if it was one of these expressions in the tree, but it's a purely internal expression that of course you can't input by typing into the code. And when we hit that, we do some stuff, right? And then this says, hey, go over this entire array of all the arguments in the procedure, flatten all the arguments. And then we emit this thing that's like, okay, pop that state, right? So these are essentially like little commands in a command buffer. And in fact, it's sort of like most of the syntax tree nodes are like the trivial command of infer the type for this node, right?
Right.
But then once in a while, there's other things that we put in there.
Once in a while, there's something fancy.
Yeah. So like, and they're all under asked utility. It's this one node type that I made for that. Let me see what some other ones are, right? There's not that many. So if we're starting a loop, I would have to go look at exactly what we do, but we needed to demarcate the loop body in some way that helps if it's a macro, I guess, right? In part, because unlike C macros, for example, macros here, they're like more hygienic macros, so they have their own local scopes and stuff. And furthermore, you can turn trivially a procedure into a macro and back. So return inside a macro returns from the macro, which means it actually just turns into a goto to the end of the macro, right?
Okay.
You can mark it if you want to insert a return into the outer procedure. You can mark it as that, but it's just a different way of doing it than C, right? So that's probably used in that a little bit. For while loops, I guess we do a similar thing. Type of, so we have this type of thing, and so if you have a struct, like if you're referring to a type of a struct, right? Like a vector3. And so if you have an instance of vector3, you could say v.x, and that's a value that you could use, right? Mm-hmm. But if you say vector3.x, right, that's a thing you should be able to talk about because it has a type, and you want to ask.
But it doesn't actually exist.
Yeah, you can't use that in an expression, right?
Yeah.
And so this is like to say, okay, you're allowed to talk about that in this range, right? So there's things like that. And so this system a little bit has evolved into something that I didn't know that it was going to be in the beginning, right? Now, all that said, I do suspect that this whole thing about making a buffer in order like this is not necessarily the fastest way to do it, but maybe these two ideas could be combined, because if it was like RPN or something, and you can imagine it's like a much smaller stack that pushes stuff, pop, push, pop, right? And it like fluctuates sort of at the bottom, right? As you handle things. Then that would be a very different design of the compiler, because that would sort of imply that you're going all the way through code gen, which actually we can't really do. Okay, so the additional piece of information is after we do the type checking, we send the nodes through the system to your metaprogram, and your metaprogram is free to say something like, this procedure is very nice, but let me modify the tree and hand it back to you. And I want you to compile the modified tree rather than the one you gave me, right? So we can't, if we were to proceed and generate code and stuff, that all that work would be wasted in those cases, which might be quite common. For example, if you're doing a profiling pass and you're inserting profiling hooks into like most of your functions, you're kind of invalidating all that work, right? So I'm not sure, like maybe there's a way in which we do all the work, but we could at least do that for the type checking, is like have it be a much smaller array of stuff that fluctuates around. If we did that,
or the metaprogramming is just on that thing.
on
Like the metaprogramming works on, RPN or something. I mean, I'm not saying this is a good idea. I'm just saying.
Yeah, I don't know.
Like,
I mean, let's just say there's different ways you could think about doing it, right? And that actually makes it. That's a major degree of freedom in this system. Let's say is like how even is this done, right?
Well, one thing, just to get one thing out there, I've never really totally understood about abstract syntax trees in general, is I've never really been clear on what problem they are actually solving. So
yeah. I mean, okay.
Just let me finish because I don't write compilers.
Yeah.
So typically, if you have a tree, the reason that you have a tree is because you are trying to avoid looking at parts of the tree because they're irrelevant to your current like search or something. Like a tree is for pruning, usually, is why you have a tree. And so ASTs are kind of confusing because they don't really use it for that. It is understood kind of from start to finish that an AST in a compiler will be read in its entirety in order multiple times. So the only thing I can think of that is what it's generally used for is so that you can more quickly change what is on one branch of it because you're expecting to make like substitutions, I guess.
Yes.
That's the only thing I can think of is why they're used. But
that is the main thing. I would say that is by far the main thing. The secondary thing is that you kind of just want your nodes to point at multiple things, and that's kind of like a tree, right? It's like if you decided already that it was a tree, you have confirmation bias in the sense that like,
oh, right.
Look, I'm pointing at multiple things, right? When
That's
in
like
reality, lots of data structures will do that.
Yes, sure, yes.
Except that in the sense that you're pointing at multiple things, it's kind of de facto a tree anyway, whether that's how it's really considered, right?
Yes. By the way, can we just pause for 1 second?
Oh yeah.
And acknowledge the fact that Twitch is currently under like a massive bot attack.
Oh great.
Like
that sounds wonderful.
There's like HOSS00312 _ and every word in the alphabet is following me. Like I just see them coming up. It's like this mother Hoss 00312 mother Hoss 00312 greasy.
Dude,
Hoss
you're getting so many followers. That's going to really pump you up the Twitch leaderboards.
Yeah, well, you might be getting them too. I'm imagining.
I'm not.
This
I don't see anything like that.
Running rogue.
Yeah.
Anyway, sorry about that, but it was just like I'm seeing the stream come by on the side. I'm like, what the hell is going on? Yeah. Anyway, okay, so why don't you go back to what you were talking about before? But I just wanted to get that.
So like, one future, if this is like Avengers Endgame or Infinity War, the one where Doctor Strange is thinking about the future.
Yeah, right.
And then that's their excuse later for why things had to happen the way they did, because that's the only possible way.
Yes. Which is true, because the only possible way it could happen is the crap they wrote down on the script.
Yes.
That's what Doctor Strange saw when he looked at
it. So okay, if you imagine that I kept this structure where things are flattened together, that's already sort of like having an index per node anyway, because like wherever things are in this flatten array is like the index, right? And maybe I don't need indices for the syntax tree nodes, because maybe I just store those as one pointer per index here. And then when I want to go look at them, I do that, right? So like this could be in this refactoring that splits the data into multiple parts. You could do, okay, you could imagine a very fat data structure that is the following, okay? There's different subsystems in the compiler. There's parsing, there's type checking, there's, bytecode generation, whatever. Each of those has, let's say it has one data structure. It's not really this simple, but let's say I even did the thing that you were talking about rounding up to the biggest size or whatever, right?
Yep.
And so they all want to make an array of things, right? If I don't even worry about, what I could do if I'm not concerned about memory, which I am, but if I'm not, I could have something like this where everything lives in an array, and this controls the indices because it's what's doing the flattening. And then for each index I have, here's a pointer to the syntax tree node. Here's a pointer to the type check node. Here's a pointer to the bytecode node, right? And that would be, that would actually not require the storage in these different systems to even use parallel indices, right? Because you would just like use the pointers, right?
Yeah, you could. Yes, right.
Now the question is, okay, obviously that's kind of dumb because it doesn't seem that hard like to use the same indices everywhere, right? The thing that makes it a little bit more complex than the parsing case is in type checking, you are significantly often referring to things that are far away that are probably being handled by another thread or something. And so there's a distinction that you kind of need to make, I think. Again, this is very hypothetical, right? But like, if I'm doing this thing and in the future when we have the type checker threaded and I'm cranking away on my function and then I hit like a global identifier that I don't know the value of yet, I kind of need to pause. Like for things that are local to the function that I'm compiling, I probably know the type right there because it's like in the data that I've been messing with. And I don't want to do any synchronization to like you could imagine the absolute most generic stupid thing is like every time you want to get the type of something, you grab a global type getting mutex, right?
Yes.
And then you're free to get it from anywhere, right? But like if I've got my local flattened stuff for my function, then I probably know the types of most things just locally. Like I'm in control of them. And if somebody else needs to know them, they could try to grab a mutex from me, right? But they're welcome to wait a while before they get that, right? And if I want to know something that's far away, then I grab a mutex from somebody else who runs that compilation unit, right? Or that thread or whatever. So like...
Well, yeah, and in my head anyway... I mean, I haven't thought about this problem for more than a hot second, but it doesn't sound like the kind of thing I would use a mutex for anyway, because, you are... It's not a piece of data that changes.
Right, it's set once and then it's fixed, yes.
Yeah, so mutexes are, I think mutex, I'm thinking of something where we're changing the value of this thing a lot, and two different threads are going to fight over what the value actually was, and that's why I needed the mutex. In this case, you'd really and this is not accurate to your problem, but I'm just throwing it out there as an example. Yeah. Like I could see a system where we've got this flattened buffer, so we know that this is the order in which we're going to process things, and we're going through the flattened buffer. Any other thread can snoop, not write to, so it doesn't even have to be a lock. It's just snoops the value. That's how far through that array we've gone. And if it's past the one it wants to know, it just looks and knows that it's correct. If it's not past it, it knows, don't look at that now, come back later, right?
Interesting.
And so, it seems to me like there's a lot of opportunities here for not needing any mutexes. Like these threads can just go, and they just occasionally snoop values that other people have written, but they're not writing to them, so there's no lock. It just gets, that number gets observed when it gets, written out.
Yeah.
right?
Okay.
And you know what I'm saying?
Yeah, that makes sense to me. But sort of the thing, I mean, it seems kind of clear to me, right, that no matter how the synchronization mechanism works, there kind of has to be a distinction between things that are close to the work that I'm doing and things that are far away, right? And
Mhm.
we just need to do something to coordinate for the things that are far away. Does that make
Um,
sense?
Again, yes, it absolutely makes sense, but I think it's not as bad as it sounds when you say far away. Is I guess all that I was trying to say. I think it's actually
Like,
because this problem happens to be a lot friendlier than other kinds of problems.
yeah.
It may be not that expensive to do the
Okay.
far one as you might
Well,
think.
I guess my impulse, and this may or may not be true, but my
Hmm.
knee jerk feeling about it is even if it's relatively inexpensive,
Hmm.
I don't want to do it for every single expression in the program, like by default, right?
Well, and just to be clear, the reason it would be inexpensive is because you do know that it's different. So, right, you would
Oh
know like
yes,
which,
okay,
right, like
yes,
you would have an idea of like which thread you were looking to, or there would be like a central ring buffer thing we were looking at. So, yes, obviously it presupposes the architectural decision you were talking about. Yes.
okay. So this is one where kind of my thought process stopped, and I didn't know where to go with it because on the one hand, what we've been saying is like, well, if you have this set of indices that gets used everywhere, like in
Mm-hmm.
parallel across these different systems, you could store the data by index. It's all good and everybody's happy, right?
Mm-hmm.
But like, if I need to refer to somewhere far away, right?
Mm-hmm.
Then I mean, maybe the indices have to be 64-bit, and part of it is like a field, like the top n bits, like the top 10 bits is like which thread is in charge of this.
Mm-hmm.
And
Sure.
if that's equal to my top 10 bits, then I'm fine, right?
Yep.
Or something.
Sure. Yep. I can see that.
But I haven't, like, because I haven't done that kind of system very much, it's just very hard for me to think through the consequences of that, right?
Well, I think so. Um, just trying to randomly in my head kind of think through the main problem. I would assume. Uh, so the first thing that I'm not sure about, and you can tell me if maybe this is not a problem because it sort of gets handled in the parse or something. But the lookup, I think, would be the most expensive part because I don't have a window into how that would really happen. So just to explain where I'm not necessarily knowing how this works,
Mm-hmm.
there's like two phases of the resolution of something that I don't know right now. One is asking where I would look up that information, and one is then looking there for the information. And the asking where part, this is the part I don't know.
Yeah.
So is that a complex lookup? Like when do we actually have these indices? Because in my mind, I could see it like, oh, I got to a name and I have to look up a name or something, and other threads are going to have to be building dictionaries of names that they saw. That then becomes a harder problem because now we have to think about how we're building this shared dictionary or things like that. So could you give me some insight into how the lookups are happening in terms of who has what information when and that sort of thing?
Well, this is completely single threaded right now, this part of the compiler. So like this is all hypothetical, right?
Yes, I'm
It's
even
just
just talking about hypothetically, what does this phase even do? Because like there a previous phase that's already run, which is the parse, or is the parse single threaded, or like I don't really know.
okay, so the parsing is multi-threaded right now, right?
Okay,
That's fine. It's pretty easy to do that in parallel. It's not a problem. It's very
okay,
happy.
and
Okay.
and what does it produce?
It produces the syntax tree structs that you saw in the beginning,
Uh huh.
with some of the fields initialized to the things that came in, and others of them are not set, right? Because those are set by
Okay.
later stages of the compiler. Um, and then from there, it goes into flatten, right?
Uh huh.
And that's where things become single threaded for a long time, right? So it goes into
Got it.
flatten. Flatten generates that dependency order. Then it gets type checked in that order. Then it gets put into the messaging system, which actually does run asynchronously from the rest of the compiler because, like, we don't know when your program is going. Actually, the
Well,
real reason is it was just easy to do, right? Like, it goes
okay.
into
So
a queue. we wait for it to go through and come back, right?
So here's my specific question then. I think I got it.
Yeah.
Um, so a function call. So the parser has outputted, has outputted AST portion of an AST somewhere,
Yes.
and there's like a function call node, right?
Yes.
What's in that function call node when the parser is done? Because I need to know what function to call. Is it just a string that's the name of the function I have to resolve, or is that string already been resolved to point at an AST
Okay.
node?
Yes.
Or you see what I'm getting at?
So the type checking process for a function call. So I have the struct here on the screen. It's pretty complicated. It has many steps. By the time we're finished with this process, okay, we can go into like what we have at various times in the middle. But so in the beginning, we literally just have the parse information, right? By the time we're
Right.
done with the process, we have everything that we need to do code gen on it. So we have a
But
pointer
just so I'm clear,
to,
just slow down just one
yeah,
bit there.
yeah.
When you say just the parse information, so we literally just have like a string, right? That's like the name of the function or something.
Yeah, and then the arguments and
Right.
whatever. Yeah.
Okay, so that is the part I wanted to get clear. So we do have sort of a global string lookup multi-thread problem here as well, which is that some other
Yes.
thread is going to see this name, and we're going to see this name, and at some point we have to rendezvous, right?
Yes. And
Got it.
so
Okay.
I'm
Yeah.
imagining, so right now, because this is all single threaded, we do this standard thing where, we start in whatever scope where you're using the identifier and then we kind of walk upward. And for a while, we're probably, if we're deep in a big procedure, for a while, we're going to be still in the territory that this compilation unit is governing over, right? Because
Yes.
it's a scope inside a scope. It's an if statement inside the
Yep.
body of the function and whatever.
Yep.
But at some point, we go outside the function because now we're looking for global variables. And at that point,
Yep.
we need to synchronize somehow, right? Now, it is
Yep.
very clear when that time happens because we're like walking up this linked list of scopes right now, right? But
Yep.
there definitely is a point where it's like, oh, okay, now what? I will say there are other ways that compilers do this sometimes. So one that Sean was talking about a long time ago that I've never done is, and this is maybe much easier to do in a single pass compiler, but you could probably do it here. Instead, there's this way of like keeping track of all the live identifiers. And then as you go down into scopes, you like push things onto that. And and then so at all times, there's not really a list traversal ever. You just know what all the active identifiers are. I don't think that works for this compiler because it's so out of order. It's like not like you ever know what all the identifiers are.
Yeah. It seems like that seems like a smart design, but it seems like it does limit it limits the number of languages that can be implemented in that design. I mean, without breaking the design. Like, obviously, at any point, you could start injecting more identifiers in, but then you're not really using that design anymore.
Yeah. I will say we were just doing profiling yesterday and today, and identifier lookup is like, it's like 4% of total compiler time. So it's like, it's not killing us, but at the same time, it's like we're going to want to make it, even if we didn't thread at all, we would want to make it faster eventually because, 4% is kind of a lot. So, but there's like no caching or like if you're in a function and you've got a variable x, right, and you're 3 scopes down, like you just looked up x like 10 nanoseconds ago, like what it is, right? And so maybe some caching there could be helpful, and maybe that's similar to what we would do for threaded coordination, right? Because after I go do some synchronization to like ask you what the hell this thing is, I probably don't want to do that again if I don't have to, right? And so I would keep some list of like, these are the things that I went and asked about in the global scope, and here's what the answers were, right? Oh, one more thing is this is a little bit of a more chaotic problem than it might otherwise be because it's not like there's a set of known identifiers out in the universe that never changes and we just need to know what they're bound to, right? Like while I'm compiling this function, other people are inserting variables into the global namespace or whatever, right? So it's like, it's that kind of problem.
Yeah.
Yeah.
Okay.
So I forget why we were asking that. You were wanting to know
I was
more
asking that because I
concretely
was trying
about
to get a
what?
handle on what kind of a threading problem we're dealing with here. Right.
Okay.
So I was trying to figure out like what all the kinds of inter-thread communication issues might arise. It's good to kind of have an idea. Like, are we doing shared lookups? To what extent can they be compartmentalized? I would probably want to know some information that you probably don't actually even have, unfortunately, because it's a new language. Because like one thing you would look at if you were optimizing this after 10 years is you'd be like, well, what types of lookups do we do most often,
Yeah,
right?
yeah,
Like,
yeah.
you'd be like, yeah, do we do a lot of, how often are functions called that are near each other versus remote, far away, in terms of
Yeah.
which, where they were in the source and all that stuff. So yeah,
Well,
it's a
like
bit
that's
hairy, but
there's sort of that question of like how many levels of hierarchy are there to the organization, right?
yeah,
It could just be there's those compilation units that I was showing you, and then global space is everything else. It could be
yeah,
that it's organized by file, by module, and all this stuff, right?
yeah,
Yeah.
yeah. Um, okay. Uh, I'm going to mention this design right now. I don't think it's a good one,
Mm-hmm.
but I'm just going to put it out there since you're kind of looking for ideas and stuff.
Yeah.
It can kick around.
Yeah.
So there is a kind of design that's very rare, but it's perhaps more interesting than good, but it's worth noting. One way to look at this problem is I'm going through and I've got threads, and each thread is like I'm pulling off one of these flattened compilation units, and it's starting to go through it.
Yeah.
And it's going to hit times when it needs to look up things remotely. So it's going to go and it's going to take a mutex, or it's going to look at some kind of a key value to see what's going on, or who knows what's going on, but it's going to have to go do some remote work and ask a question.
Mm-hmm.
There is a slightly different way to do those when you're talking about things like lookups, which is what you can do instead is hash the thing you're looking up, and use the hash of the thing you're looking up to send that compilation unit over to the thread who's responsible for that thing. So again, not saying it's a great idea because I don't know anything about your design, but
Oh, like
there
say you finish this because I can't do it
because
right now.
so I stated more broadly, it is designed where you send work units around a lot
Mm-hmm.
instead of sending lookups around a
Yeah.
lot. So in
That
other
doesn't
words,
sound like the right thing to me, but it's an interesting different way to do it. Yeah.
yeah, that's why I wanted to bring it up. And the times when these kinds of designs excel is when the lookup becomes dominant. Because if you use a design like that, then what happens is maintaining whatever this complex lookup structure is done locally on each thread, and they never have to coordinate with each other to do it.
Yeah.
So it's just an interesting thing to be aware of. It's like it's a different design that favors hash locality of the lookup and never having to synchronize any of that stuff, but it bounces work around a lot. So if the state of the work is the thing that you want cached the most, then it's a bad design,
Yeah.
right?
Well, I mean,
Anyway,
one thing that occurs to me is if I kept this flattened structure for a while, right? I can always like identifiers are an interesting case because they're basically approximately the only real action at a distance mechanism in a programming language like this, right? Like that's how you talk about something far away, usually, I think. I don't know. I'd have to think about that, but it's basically true. And they're also leaves, right? Like identifiers don't point at a lot of other expressions. It's just the identifier, right? And so like in that flattened array, if I decided like, oh, we hit a thing that we don't know and we're going to have to go do a lookup, I could actually read ahead and look for other things because they don't depend on anything in the sense of this like RPN.
yeah,
They wouldn't push anything in the RPN sense, right?
yeah,
So like that would be a way of optimizing that kind of synchronization. That said, you do take the the cost of searching ahead for identifiers, right? Or it's quite possible that when we do the flatten, we actually build two arrays of identifiers and everything else, right?
Yeah.
Because then like the identifiers don't frickin' depend on anything, right? Like I think that
Yeah.
that would be possible and make sense.
There's another thing you could consider as well, which is collapsing names down during parsing so that you really don't have identifiers in that way. Like, you could imagine the parse phase, each of the parsers outputs a collapsed set of identifiers lined up to indices, right?
We actually have that for like speed reasons or something. I don't know. So originally, before I was thinking about, threading at all, right, and I was just getting things working, there was like a global table of, basically, if you have an identifier, it points at this struct in the global table, and then everybody that's the same identifier has the same pointer, and then, you can compare identifiers very quickly just with a pointer compare. Of course, when I started parsing in parallel, I modified that design. So now there's a separate table per, per thread, essentially.
Yeah.
So it's kind of halfway there to being globally unified at this point. And there may be some benefits to that. It might be a waste of time. I don't know, to do it the way that I'm doing it. But that is definitely a thing. Like, that's actually how it used to work, was like everything was the same pointer.
Because that's kind of interesting if you linearize all the names. If you take all those tables, so after you're done, you fold them 2 by 2 so that, all your threads before you head into this next round actually take a second to build one string table. Depending on how fast you can do that, it does have some nice things, because from now on, there's never any locking anymore on the name lookups, right? You want to know, you need to call a function, you have the name, right? You can generate the index from that name, because presumably this thing is like in hash order or something. I mean, you would probably have, it was somewhat sparse hash table, I would assume, is what these would go into, but I don't know.
Well, okay, so keep in mind it's going to keep changing during compilation, so it's not like there could be one fixed order.
Okay,
ever,
so
but
and identifiers get like added or
yeah,
whatever.
you could keep appending and increasing the number for sure. It just couldn't be like a perfect hash or something like that.
So, where do the new names come from? From the metacode?
Yeah, you can add more. Well, so first of all, it's not like everything parses and then everything type checks and whatever. It's like a lot of stuff's parsing, and then we start type checking and doing all this stuff while other stuff is still parsing. And then when your metaprogram gets messages, it could say, here, I'm generating more code that you now parse and whatever. And the semantics of the language are such that you're allowed to do that after compilation has begun and after you see things, right? And so that's actually where we get a lot of power from. So I don't want to change that.
No, you shouldn't. Yeah.
But that is not, that doesn't prevent me from assigning a unique integer per identifier. It just means that data structure has to look different and maybe be less efficient
and it might
than we
not.
otherwise would like.
Yeah, it might at that point not actually be worth it, right? Because if you do too much work to actually get it into that form, then you haven't really saved anything.
Yeah.
Yeah, so that is going to be the nastiest part, I would assume. Like, because your threads, from what it sounds like to me, could run very independently in this phase. It's really just that lookup that will start to tangle them up, right? I mean, is that a fair assessment?
Maybe, question mark. I mean, the problem is the type checking phase is, it's like it's the biggest part of the compiler by size. Like, if you count all the sub pieces of it, it's probably, let's say it's probably less than 20,000 lines of code, but it's not that much less, right? And so, I don't know what all that's doing. I have no idea what's going on in there, because I wrote it over.
Yeah, there could be something else that we're not thinking of. Yeah.
Yes. However, I will tell you that when I was thinking about, I've been thinking about vaguely, how am I going to thread this for like 2 years, right? And like, the identifier lookup is seems to me like the main feature of it to be concerned about. Do you want to talk about a specific sub-problem that I had that
Sure.
came up recently? Because like maybe like okay, there's a peril of there's an advantage in a peril. Like if I try to solve one very specific problem that's actually maybe easier than the type check problem, right? And that could suggest answers to the other things that might be helpful, but at the same time, maybe not looking at all the other stuff is bad, right? Because then you come up with a design that doesn't solve the whole problem. But here's okay. I'm gonna run this telemetry build really fast. We'll talk about why in a second. Okay, so as I mentioned a long time ago, the basic model of the compiler is you start with the syntax tree, and then all the other junk that all the other phases want to do just has members in there, right? And it gets filled out. The type of a node is one of those members. Another one, though, is when we send you these messages to the metaprogram, we want to give you certain guarantees about that, right? So for example, because we want it to be easy for your metaprogram to reason about what it's seeing, right? So for example, so there's this process of translating our nodes to the actual format that you see, right? Because we're providing a stable format over time. And of course, your program doesn't care about a lot of stuff that the compiler cares about and whatever, right? Now, that includes, for example, what identifiers are bound to, right? So if there's an identifier X and you're like, what is X? You can see it points to some declaration elsewhere in the program, right? Now, for example, during that export process, we have maybe a similar thing, but it's a little bit different and a little similar coordination problem where it's like, okay, that declaration, maybe it was already exported before we decided to export this function. And so X already has something to point at, right? We want to guarantee to your metaprogram that we point at one unique copy of that declaration, right? So you find it easy to reason about that. You could put that pointer in a hash table, whatever you want to do, right? Okay. Now, maybe that's questionable, but that's been the assumption that I've been operating under, right? So then, well, there's other things that could happen. There's like, well, I'm trying to export X and I want to tell you what it links to, but we haven't exported that yet. So maybe we're going to wait until that thing exports and then we'll finish the export of this thing or whatever, right?
Sorry, what do you mean by tell you what it links to? What is the what exactly?
So we're giving you a node. So there's a user-facing identifier node, right? And
Yes.
that says, here's the name of the identifier. Here's the type
Yes.
of the identifier. Here is a
Right.
link to the declaration that it resolved to, right? So, because there could be a lot of X's in your program, right? And you want to know actually which one, because you don't want to have to like somehow try to duplicate all the
Okay.
logic of the compiler.
Sorry. I'm sorry. It takes me a while to come up to speed here. I'm also my brain is probably is probably a little bit slow.
It's late at night.
At the moment. So this is for the case where like I'm in some function and I talk about X. It's going to give me like a pointer back to the int X line that was like somewhere back in the program.
Yeah,
that kind of thing,
or in the global scope or somewhere.
or right, or wherever
Like-
it was. So that is that
Like
what we're
if you're
talking
in
about?
your text editor and you want to right click and say go to definition.
Yes.
Right? This
It's
gives
gonna-
you
it's
that
gonna give me
information.
that.
Yeah.
Okay, got it. Yeah. Okay.
Yeah. So the way that I used to do that was exactly the way that I do it with the type checking. So this messaging copying whatever setup system is asynchronous to the rest of the compiler, but there's only one thread doing everything, so it's synchronous to itself, right? So
Right.
what I did was I said there's just one pointer on the syntax tree that belongs to that thread that's like the
Right.
if it's already exported, here's the node, right? And you could just check that slot. And if it's already exported, then you just copy that pointer and now you're done. And if it's not, then you do something, right? But I was thinking, okay, this works pretty well for what I'm doing right now. It is in parallel with the rest of the thing. It's kind of okay, but like I've been thinking, I want to start factoring the tree apart and store this kind of information separately, right? So why don't I do something to store this kind of information separately? And I was thinking maybe we'll have an index per node or something, and I could have a flat array of these things or n flat arrays. Like it's a little confusing, like how many arrays there would be and how you know what they are and stuff, right? But I was like, okay, in the meantime, I could use a hash table. If you remember, I was messaging around about how to do hash tables really fast a couple of months ago, right?
Yes.
And this is what that was for, because I was like, okay, instead of storing it on the node, I'm going to make a hash table and just try to make it really good. And I used the AES instructions that you suggested, the like two or three step. And we got it down to like 2 tries per insert, or like on average, or so. It's like not that bad. Or actually, no, if you make if you spend more memory to make the table bigger, it's like 1.6 or something, right? Which is like, okay, you're starting to hit diminishing returns at that point. And the problem that we discovered, why am I not seeing? There we go. The problem that we discovered today is that hash table does get quite big. Oh, when I did that, the assumption was, I'm going to be able to, right now, I'm just going to put every node that we export into this hash table along with the exported result. But later, it's probably not true that most nodes need to point at previously exported things, right? So I'm going to be able to thin the hash table out and not store most things in it. Like maybe certain types of nodes never get externally referenced or something. Like maybe identifiers don't. I don't know, right? That didn't turn out to be the case. For whatever reason, I'm not sure. But like I was running statistics on it, and like I did a whole like 4-hour stream one night where like I couldn't figure out how to reduce what goes in the hash table by anything. So that's a whole thing.
Can you explain to me though? The only thing I'm not entirely clear on. I mean, I could guess, but why did you want to remove that pointer from the node? Like was there a particular problem you were solving, or you just like
because
feel
the
like
assumption
doing that?
was that eventually I want to have some kind of clean separation where the syntax tree data is separate from the type inference data and all these things. And this seemed like a relatively easy area to experiment because it's pretty simple. It's pretty self-contained, right? And so I was just trying to do that. I was like, let me just try this and see how it goes. It's obviously very easy for me to switch back, right? If I want to. And so I didn't realize this, but like the hash table, it's one of these things where we double the size of the hash table and rehash, right? And I assumed that it wouldn't be that bad because it's in parallel to all the other stuff. And early in compilation, that's fine. But later in compilation, it's like we're kind of waiting for your metaprogram to do stuff. And so when we're compiling Sokoban, there's this giant hole of 30 milliseconds where we're resizing the hash table, which is maybe that's a lot slower than it should be. But I forget, there's like 2 million nodes in it or something. I don't know. Like it's guess, way too big to do something this simple, I guess, is what I'm saying.
So it doesn't sound to me like something I would want to do anyway. Like we can totally talk about that.
No. I'm not saying that. I'm not saying this is a good idea. It's just like what I tried to orthogonalize that piece of data.
Let me suggest something to you because maybe you haven't thought about it this way before. So I'm just gonna say it, but in case you haven't already thought of it. So what I usually do in situations that look like this particular one is I don't try to store the data in separate groups like that. So for example, if I have a thing like AST, like you were talking about, and I've got AST nodes, and I have like some of the AST nodes are going to have this pointer, and like some of them aren't.
Yeah.
Which I assume is what we're kind of talking about here.
I mean, they're all going to have it, really, probably. Well, okay.
I guess I'm trying to wrap my head around why you wanted to remove it, so maybe I'm still guessing wrong.
But so the idea, okay, imagine that I have some kind of threaded system with, like, okay, I could keep exactly the syntax tree nodes that I showed you at the beginning, right? With all these different fields. And I could
Yes.
somehow just thread that and manage the complexity. First of all, would seem probably really confusing to me about when do I know, like the data structures certainly aren't helping tell me when I can manipulate things and when I can't, right? But there's maybe false sharing issues there, right? Like if there's a messaging thread and I write into the messaging pointer, is that in the
Right.
same cache line with like
Right.
something else that somebody else is trying to do, right? So for those
That is
reasons,
exactly what I was going to suggest after this. Was what I normally do is I just make 64 byte blocks and I put the pieces, I put them together, but I put the pieces into the block where they go for threading. Which just doesn't sound like it solves the problem you were talking about, which is that you don't like the optics of it. Like you don't like the way it looks to you for understandability,
well,
basically.
I will say
Like
my ability to achieve progress on the compiler has been limited by complexity of my
yes.
understanding of the compiler the whole
Yes.
time
Yep.
before it's even threaded, right?
Yeah.
And so I'm just very concerned about that. Uh,
Understandable.
but I don't
Yeah.
understand. So you said like 64 byte blocks, right? Which
Yeah.
is
So what
obviously
I'll
to avoid sharing or false sharing. But then what? How are those organ? Like, what
yeah.
do you
So
mean?
what I then do is I'll like, and I do this separate from threading.
Yeah.
It comes up for threading because you want to not have writes that collide with each other, obviously. Um, Although if you're not doing them locked, it's actually not that bad because if you're not looking at values at the same time you're writing them, then you don't really have to wait. Like your CPU is not necessarily waiting on that piece of information. But all I was going to say is even when I don't, I find that I oftentimes want to have like a struct, and you can start to break that struct up into pieces. But if you do, there's usually a cost associated with it. If you in either case, like even if you have a separate array that is indexed so that you can look up directly in it, there may still be a cost associated with that um, for some other reason, like, oh, now I've got to have these more pointers around or whatever. So what I'll sometimes do is I just make blocks of 64 bytes and I put things in the blocks based on the likelihood that a particular thread or person will want to access them together, so that you only pull in one of the 64 byte blocks when you go to do some work in it, and you don't pull in the other one. Whereas if you don't do it that way, then you end up in a situation where you tend to pull in the entire struct, even though you only needed like, 16 bytes out of it or something, right? Um, so I do tend to do that. I don't tend to pull things out because I find that if pulling them out usually ends up with a problem like you're having here, where it's like, okay, the cost of having the thing outside ends up costing me more than what I saved by not having it on the inside, right?
Well,
Um,
but like if
but
we
yeah.
had a scenario, if we had a scenario where there's an index per node that I somehow know what it is,
hmm
then
This
pulling
becomes
them
a lot
out is
easier.
very easy, right? Because it's just
Yes.
like I just have an array of those, right? Of those
Yes.
pointers. But so,
But there's one other thing, just to say all the full trade-offs there, right? There is
yeah.
one other thing that happens with these, which is that it's only true if you know you really only access those things. The nice part about bundling is you can pick the things that tend to get access together. If you have something like one pointer per node and
Mm-hmm.
you pull that out, then the problem is when you go to access that pointer, you're also pulling in 8 other pointers that you didn't need to access. So your cache utilization goes down by, what it's now 1/8 of what it was, because every time you go to look up something for that node, you get 8 things.
Yeah.
Another way to look at it would be, imagine if you took the structure and completely disaggregated it. Well,
Yeah.
it gets much slower, even though you still know exactly where to look, because you always pull in 8 other nodes as things for every one pointer you looked at for you. So
Yes.
it's worth putting that on the table too.
Yeah, I'm not sure. Again, maybe it's because it's late at night and I'm stupid, right? But I'm not sure how to increase efficiency of that in this particular case.
Yeah, because maybe it just only ever wants one pointer, right?
But there might just be a different way of thinking about the problem. But
Yeah.
like it's just I pulled up the telemetry to show like the hash table is definitely not it, right? It's like not
Yes.
it's not the
Yeah.
way to do this.
Right. Yeah.
Maybe if I can, I mean, maybe when I was doing the analysis, I was being stupid in some way, and actually most of these nodes, my assumption had been that at least 90% of the nodes would not be necessary, and so there might just be like something about the way I don't know. Yeah, but either
It's a
I'm going to
little.
want to do that analysis no matter how they're stored. I don't want to store 10 times as much data as I need to, right? So at some point I need to figure that out.
It's a little confusing because it sounded like something that wouldn't be that often needed, but maybe your code just the meta code just always asks. Is that because it sounded
Well,
like you were saying it was only necessary for asking the metacode, but maybe it's used for other things.
um, well, no, I mean, the job of this particular thread is to prepare that data for your metaprogram, right? And so,
Oh, whether it ever asked for it or not.
yeah, I mean, we're assuming that in a decent
Okay,
sized program, you're probably
I
going
see.
to look at a lot of it, right? So
Okay, okay,
you
okay.
don't ask for it necessarily on a piecewise basis. Okay, so another thing about the design of this system is all the metaprogramming stuff is meant to scale into the future. So
Right.
it's designed to be inherently parallel. So like
Okay.
the way it's structured is you get messages that come in, right? And the
Right.
messages are like this thing is compiled. And you can there's some flags you can set up at the beginning of a compilation that are like do you want syntax trees for everything, right? But if you're doing non-trivial stuff you probably do.
Okay.
So instead of having some like high latency thing where you like go and do
Right.
a request and then we
It
work
just
on it
kind of
for a while.
pushes the data forward. It's like, here's the tree.
Yeah, you just sort of it comes in as it happens, right?
Gotcha.
Now that actually makes things a little bit probably less convenient for the person writing the metaprogram because it's like it, you can't just you know if you want to know what like if you waited till everything was done and then you wanted to look up the factorial function you just can, right? But like
Hmm.
here it's like well maybe that's not ready yet. Like maybe you got something that called the header for the factorial function but the body's not ready yet.
Yep.
And that's just we're just saying that if you're like okay if you're writing a metaprogram and you want to be dumb about it you always can just wait till the finished message happens and then look through the data structures, right? But that's going to be slow, right?
Right.
um, but you can do that. But if
Right.
you
Right.
want to be fast you can also like handle things as they stream in. So that's the design
Yep.
of that.
Got it. Got it. Got it. Okay. Yeah. I mean, I guess what I would say is assigning indexes obviously helps with this kind of thing.
Hmm.
Storing a single pointer as the thing you're indexing in, though, doesn't sound great. Um, so that part, I'd still be like, well, uh, you
Yeah.
know, could we not try to figure out a way to do more than that? Um,
Well, it's interesting. It's weird because if I'm like it depends a lot on like how I manage to analyze and separate the data in some sense, right? Because right now, because I couldn't figure anything out, we do this check for every node. Like we do just like you recurse into the tree to flatten, we
mhm.
recurse again. We don't assume the same flattening order because it's like not really correct or something. I forget why.
Okay.
Um, but we re-recurse from the root, and for every node we say, is it already exported? No. Okay, do this. Okay, yes, no. So actually, a lot of these are probably contiguous or close or whatever because they are the nodes kind of that we parsed with some substitutions and whatever, right? But
Hmm.
then sometimes they're not, like when you refer to something far away. And so the fact that they're actually kind of local to each other is faint comfort, because I sort of feel like most of that work, like we shouldn't actually be checking most of them anyway. We should just know that a lot of them aren't exported. And the fact that I don't know that kind of bothers me.
I see.
Yeah.
And so there's definitely some like holes in my understanding of this that make it a little bit difficult
Oh
for me to
yeah. I
think
mean, it's a
through.
complicated system that I've been working on for 7 years.
Yeah.
Like,
So
no
like,
doubt.
there's a lot of things where I'm like, okay, wait, I don't quite see how that's happening. Um, so when this thing, what this thing is actually doing for what you're calling an export, you're exporting it to the user's metaprogram loop. Is that correct?
Yes.
So the phrase export in this context means putting it into a a buffer or something that they're going to get, or something like
Yeah.
some way that that's getting shipped off to the user.
Yes. Yes.
Um, and so the pointer here that needs to get generated is getting generated off of the same AST that the type checker was running off of. Is that correct? Or not quite?
Um, yeah, with the caveat that the type checker makes some new nodes and whatever, right?
So
Um,
it's the same data structures. They just have been permuted slightly, presumably, because the type checker
um,
wanted to do stuff like
yeah, I mean
add some nodes,
the source of
rearrange
this
them,
export process is those same AST nodes, right? The
and
target is a totally different user format. And like it's actually questionable by while we're letting degrees of freedom fly, right? Like
yeah,
is a syntax tree the best way to export information about your program to your meta
right,
program, right? I don't even
right.
know. It has, like
So
we
what
were
I was
saying,
gonna
trees have some benefits, they have some disadvantages.
so what
They're
I was
very
gonna ask is
large.
why isn't the uh, why doesn't the type checking output the exported node set? Because it's got all the data, like it's warm, and it already had to do that lookup to find out what the thing was. Why isn't it the thing building the stuff that gets sent? I think I missed that was part of it. Like, because I guess the only thing I want to make sure of, because I didn't hear if you said it or not,
Yeah.
was this wasn't something where you decided to just like pull this off into a separate thread because you were like, oh, I'll save some time by moving this out for now, but later when the type checker is more threaded, I won't have to do this anymore, right? Like is this
Yeah.
even something that has to happen this way if you threaded the type checker?
I'm not completely sure, right? So
Okay.
there is a stage in between these of compilation that's like a separate queue.
Oh.
It's also single threaded. It's in the same thread as the type checking,
Okay.
but it's like the
All right.
sizing step, right? Where, so if you have
Okay.
a struct, for example, right?
Uh-huh.
How big is the struct? Well, it depends on what the types of all the members are, right?
Mm-hmm.
And so, but you don't want to need the type of this. You don't want to need the size of the struct in order to allow things to compile that only need the types of the member or something, right? And
Yeah.
you don't need like the memory offset into the body of the struct until code generation, right? And
Right.
so there's this extra stage that does things like size structs and whatever. And you actually,
Yeah.
so the size, this is where it gets like where the answer is kind of I don't know a little bit, because in
Right.
principle your metaprogram wants to know the frickin' sizes of structs and stuff a lot of the time, right?
Sure.
However, if you demand that we don't export that data, I think it is possible that there's just some circular dependency situations where like you can't do it or something, right? Well, for example, you have two structs that point at each other, right? And you want to
Mm-hmm.
export that data, and then maybe other people point at that, and like I implemented a thing, and this is not something I'm super happy about, but
Mm-hmm.
sometimes we can send you information that says, here's the node for this struct. The struct like isn't done yet, and check later and it'll be done. And I don't like that because it's like maybe something you have to think about when writing a metaprogram.
I see.
However, I think it may be necessary for this to work, right? And so, but that said, that would still fit into this thing that you're talking about because you would just like,
Yeah,
you would make the
that's
not
what you
done
would
version
build.
during type checking.
Yeah,
So
because
maybe.
that kind of strikes me as more the solution I would look at first, unless you get in there and go, oh wait, no, well, which probably often happens when you work on this compiler, where you're like, oh crap, yeah, I forgot about the
Dude,
fraudulator,
I have done a
right?
thing. I have multiple times done a thing where I spent a week changing how something worked and then hit a roadblock and I was like, "Oh yeah. This
Yeah,
I can't
yeah,
do this at
yeah,
all because of this
yep,
thing that by the way
yep.
I knew about a year ago but then didn't
You're
write it
right. Yeah,
down."
yeah.
Like,
So that may be the case, but because I haven't heard it yet,
yeah.
I'm just gonna say that would be my first thing. Is like, can I just integrate that into the type checker and then focus on inflating the type checker? Because while that is hot,
Yeah.
that's going to be the fastest place to do it. And you don't have the problem you're talking about before where some other thread is touching this value, which, like you said, is confusing, right? So that seems the
Yes,
best of
I
both
would say
worlds for
that that's
that.
a possibility.
Yeah.
I will say that kind of what I'm looking for, and this might not be right. Okay, so the thing about the type checker is, as I said, it's the most complicated part of the compiler.
Yes.
Maybe that's so. What I always was doing, it won't sound like it because what you just said was, let's merge these two things that don't have to be separate. But for the
Yeah.
most part, when writing this compiler, especially early on, I tried to minimize the number of stages in which things happen, right? Because
Yeah.
again, that's one thing that academic compilers or even like LLVM or whatever does way too much of is like,
Yeah, they can
let's do
they spiral out of control with all these intermediate representations and phases
just how
and
many passes you do over the data
oh
and
god.
stuff, right? And so this
Yeah.
is actually what you've mentioned is one place where I probably could have put it into one pass, but I think part of the reason I didn't is because messaging came later and I wasn't sure about it and stuff or whatever, right? But in general, so type checking like kind of does a lot of things besides type checking. It's sort of really everything you need to do between after you've parsed and until you have all the types. So like
It's really an
identifier lookup
inference.
isn't
It's really an
really,
inference pass, right? It's like it's inferring all of the things that weren't made explicit in the program by the programmer that
yeah.
are because it's convenient because you could have the programmer put in a number that is the function to call.
Yes.
But it's a lot better if they can just type a name and then you tell them if maybe the name doesn't match anything.
Yes. So
Um,
in that spirit of minimizing passes, I think what you're talking about would fit into that. I do think there's already problems just in the type check where it's again like we're doing the flatten first and then we're going through everything again. So it's already not hot, like even before you
yeah,
talk
yeah,
about messaging.
sure.
But yes, that would make sense. The thing that worries me about that, or it doesn't worry me, but it's like I kind of can't do that for a while because the problem is the type checker is the absolute hardest thing to make asynchronous, and so it'll be the last thing.
Hmm.
And so other stages are probably easier, like generating bytecode, generating machine code.
Right.
Um, those things are easier to
Yes, certainly.
parallelize. Generating debug info, all that stuff.
Yeah.
Hopefully, like I didn't write most of the debug info stuff, so hopefully it's not a nightmare. So
Right.
that's kind of like when you say that's the first thing you would do, I'm like, well, actually,
Well, oh, sorry. When I said
you
first
know,
thing I would do, I meant on the problem that you stated, which is what do I do
oh,
about
what do
these
I do
hash
about this
tables?
specific? Yeah.
Yes,
Well,
I
that
was
might
like, the
be,
first thing I would do is say, can I just roll that into the other pass because that's when the memory is going to be live anyway.
well, okay. If that's the answer for this particular subsystem, I could just put that pointer back over there, right? And
Yeah,
then we save 30 milliseconds on Sokoban and
yeah,
everybody's happy, right?
yeah.
Um, as like if I know that it's not a forward step, then I'm perfectly happy to do that, right? But so then the question is, what makes sense for these other things? Because like generating bytecode or whatever is not. I mean maybe you could do it at the same time as type check. Like I don't know. Like I don't know. It sounds hard, but
Well, I mean, you can't do it at the same literal time as type check, obviously, because, like you said, you need to do your sizing.
Well, actually, there's a
Um,
bunch of things. Okay, so the way
so,
trees are arranged, like if you take the address of an identifier, right? The identifier is the leaf node, and then
mhm,
the address operator is one node above that. So you can't
yep,
just go and generate code for the identifier first because you'll like generate the R value or something, right? And you can't take the address of something that way,
yeah,
right? You have to like you do kind of have to go root down to generate code.
yeah, and
Um,
also there's a limit to how many things you can fold into one pass because you have to rearrange things potentially too. I mean, when you're going to start wanting to do optimizations and stuff, you're probably not going to want to. There's only so much you can do if it's literally in line with the freaking type walk, right? Um,
Yeah, I mean, maybe it's just
so
interesting to think about, like, what if I tried to put as
yeah.
much as possible? Because that's how compilers used to work. Is
Well,
like they
it's
would just
how
do
you get a
everything.
fast compiler. Like
Yes.
that was my understanding of how like Turbo C work or Turbo Pascal or whatever, right? It
Yeah.
was just like it just the string comes in one end and the code comes out the other. It's a little thing that turns the crank, and there's not like 50 IRs or anything. It's
Yeah.
just it's
It's
as
just
direct
with
as
this
possible.
feature set, especially, I just
Yeah.
can't quite do that, right?
Well, and it like I said, at some point you it's still a fast compiler. So at some point you want to be like, you don't want to just focus on speed because if you have to start giving up features for that, it's a
Right.
bad idea, right?
Yes.
So
Yes. Yes. Agreed.
because that's the fastest thing. The fastest thing is to pick the features of your language to be only those that can be compiled
Dude,
in
if I
in
was
order.
making a Fortran compiler, it could compile
Yes.
so fast.
Yes.
So
Exactly.
fast.
Yeah.
Yeah. Um, Anyway, so I don't. My question, I guess, is when I wake up tomorrow on my awesome marathon stream where I just start trying to do all this stuff and it turns into a total mess and I'm sad.
Yes.
Um, what do I do? Okay, so this part, I think I'm agreeing with you that maybe the thing to do is just switch this back. Like, even if I end up not doing it during the type check phase, it's just better to get that freaking hash table out of there. Like, for
Yeah.
now.
I,
Like,
I
it's
don't see the
just, I
point
don't
of that
want
hash
that.
table.
Yeah.
Yeah.
Um, so I probably want some way of referring to nodes by index, right? Like that's just a thing. Um,
Probably, but again, while I appreciate the thing you were saying about how you're like, this is confusing when I look
yeah.
at this, struct, because I don't know, obviously at a glance, like exactly what's happening here. And so, I'm going to be like, well, I understood it when I wrote the system that writes this pointer, but then,
Yeah.
6 months from then, and I went and shipped Braid Anniversary, and I wasn't even thinking about the compiler for six
Mm-hmm.
weeks.
Yeah.
And I come back and I'm like, I don't remember how the frick this pointer got set or when.
Mm-hmm.
Totally valid. The only problem with that is that I just you incur a lot of costs if you have to start doing things like making an external hash table because you get
Yeah.
confused
No,
about what the
I
pointer
agree
is.
with that.
So the question is, can we maybe turn that into a different kind of problem and say, how do we change the notation or how do we change something else that can make this clearer? Like can
Yeah.
we label things with phases or do something where we don't have to give up the convenience that these are just put together? Because for all we know, adding indexes is just making it easier on us. But actually, if we just notated it differently, you wouldn't even have to go through that work, and the pointer would have just been fine,
Yeah.
right?
Well, okay. So I think that that's the case in the sense that, like, while you had started talking about that, I was thinking, like, yeah, there's a set number of phases. Like, there could just be comments in every single node definition where we list the phases in exactly the same order and the members are stored in that order, which is a little bit weird, but like it just makes it maximally understandable, right?
Well, and the other thing I was thinking along those exact same lines is, could we write some code that helps us with this, right? So, like, you can imagine uh yeah, and as I'm saying this, I'm like, although you can imagine it, but can you even really do it in C? So here is I guess where the uh yeah, where that I do. But you could imagine something that does some snapshotting diffing for you. Like you could imagine something that looks and goes like, wait, like why was this variable changed in phase two? Like I'm gonna assert on that or what? Like you could
That would
imagine
be
some
hard. I mean,
right.
yeah,
Um,
I see what you're saying totally. That's something I would rather do in my own language than in C++.
well, that's what I'm saying. You like can see it's
Yeah,
like okay, it gets a lot harder. But you could imagine doing the lighter weight version of that, which is like, all right, at periodic times, I save a copy of this struct off in debug mode, right?
yeah,
And then I do a compare later to see, and it's like I'll sort some things. I've definitely done things like that in the past, just to if I want to be extra certain that I'm not screwing something up. But
yeah,
the notation I think would be the biggest thing. If you can come up with a rubric for like once you start to develop your thread strategy and how those things are going to work, if you can come up with a rubric of like, oh, there's a way to notate how I'm thinking about these threads and how these things are accessed, you can just learn that, and then I don't think it would be a struggle anymore. If you just kind of have all the stuff in the struct, I totally agree. Like
yeah.
I would assume I would end up in the exact same situation you are, where I'm just like, I don't know what the hell is going
But
on
then
here.
what about the false sharing kind of issue there, right?
So the false sharing is actually not a problem until you go to optimize those. So to get things working correctly first, you can focus just on making sure you're talking about the phases correctly or whatever. The false
Right.
sharing is only something you have to think about once you know your thread
Yeah.
setup,
So one
right?
way, one
Because
like, yeah, okay, I get you. Like a low
right,
tech way of doing it could be, and this makes code maybe a little bit more verbose, right? But like, I could have a struct inside, like I could have a struct called the code gen struct, right? Local to
you
every
could
node, and then those
you
members
could
are just on there. And if you see code gen dot whatever
yep
in files where it's not supposed to be,
yep
then that's bad, right? Like that might be a
yep
way to do it.
you totally could do that. Yeah,
Yeah.
yeah.
Um,
And so one of the thing that stresses me out um, from like looking at that code,
yeah.
uh, which may not stress you out, but I just from having looked at the when you were kind of showing the structs before,
Mm-hmm.
um, I do get stressed out about the C++ single inheritance array model. So like this, what you've got on the screen right now.
Yeah.
For multi-threaded programming, things that stress me out about what you just had on the screen there, that AST node or whatever,
Yeah.
it appears to have disappeared. But it was like the one with the arrays in it that was
Oh,
up when you first
procedure call
flipped.
maybe? This
Yeah, it
one?
could have been.
Yeah.
I'm lagged, so I have to
Okay.
wait
Yeah.
till
Of
it.
course.
Sorry. Yes. So like this sort of thing stresses me out a lot for multi-threaded code programming for the following two reasons, which may not stress you out, but I'm just bringing them up because since you're doing stuff tomorrow.
Mm-hmm.
So I never really feel super comfortable with the C++ like I inherited from this other thing. And the reason for that is I don't, and maybe you do have a way of working on this, but I don't tend to really have a way of knowing what that ends up being in terms of uh like how these things are laid out in memory,
No, you,
you
you
know?
actually know that in this case.
No. I mean, so like I tend to like to know that each one of these things starts on a cache line boundary,
Oh, I
right?
see. I see.
And so you can do it this way, but usually but so the C++ inheritance part is not the part
I
I
see.
don't mean to
Yeah.
pick on that. I just mean the idea when people tend to write structs that look like this, they tend to be doing it by like mallocing stuff, uh, or having a push buffer where they push them on, right? And they don't necessarily know where things are. And so the reason that that stresses me out because each thing's dynamically sized. And
Yeah.
sometimes you can do that, but you have to make sure that all of your stuff is always 64 byte aligned. So, for example, if I was going to do this, I would usually have at the end of this, right after the semicolon for the struct, I would have a
Mm-hmm.
thing that's like I have a macro called assert cache line aligned, and I put the type name in there. and it just asserts that the thing works out to mod 64 equals 0, right?
That the
As a
actual
compile time
size of the
assert.
type. Because when I allocate these, it's just easy to bump the pointer to the next cache line. So I don't do that right now, but it would be easy to do that.
You
So
could
I
do
guess it's
that
a
as well,
question of way is better, I guess.
but then you're wasting the space. So I like that assert anyway because it lets me see how much more I could add while still right. So I always pad the things myself so I can see how much space I have
I see.
in a
So
64. Yeah.
okay, so you're doing the opposite. I thought you were saying you just want to make sure where it starts, but you're saying also you just want to make sure that you don't exceed that limit. And if you
Yeah.
start to, then you want to think harder about what you're doing, right?
Right. So if you look at like multi-threaded code that I write nowadays, like the past 2 years, they
Yeah.
all have like all the structs, all at the end of them are like assert that this is 64 byte aligned or 64 byte aligned in a multiple. So four of these fits in
Yes.
64 or whatever, right?
Yes. Well,
And
this
the reason
procedure
I do
call is so big that it's like it's
right,
several, right?
but it no, it's just mod 64. So what I mean is if one is too small.
Yeah, yeah, yeah.
So sometimes I have things that are small and they fit multiple in a cache line, right?
Yes.
Um, and so that usually I like to do because then it just keeps me in the mindset of like never getting I don't get confused about like the false sharing or the stuff like that because I just know that everything's laid out clean and I don't have to think about it.
Okay.
So that was one thing that I might recommend because it's easy to do and it helps keep you out of trouble
Okay. So
when you
so
go to do it.
so you would say then that in that kind of case you're not really worried about efficiently packing things into the minimum amount of memory, right? You're just more worried about managing cache. Because it's weird because, or I guess you care about both, right? Because
You
like,
care about both, sure. Yes.
I don't know.
It's more so the reason I say the word stress me out, that's what I said
Yeah,
originally,
yeah, yeah,
was because, and maybe this is like still, I feel like I'm okay at multi-threaded programming now, but we'll see, see in 5 years if I still say that.
yeah.
Maybe I'll be like, oh yeah, I was kind of crappy. Multi-threaded programming isn't that hard, but it's not that easy either. And so one of the things that I find that helps me is to make sure that I'm just thinking through the actual way the computer is working at most of the times when I'm looking at my program. And so really what it is it's a way of me saying, look, the way that threads communicate with each other is in 64 byte chunks. That is just how a computer works now, right?
Yeah.
So when I make my types, I like to know that I'm thinking about the 64 byte chunks that it is using. And
Mm-hmm.
so sometimes you are thinking about what you just said, which is I'm trying to reduce the total number of 64 byte chunks by like packing this crap in there and like, okay, there's an S64 in there. I know I could get that down, so let me do that or whatever. That's
Yeah.
totally fine.
Yeah.
But other times it's literally just for in my own head, keeping myself thinking about the fact that what multi-threaded programming basically is it's figuring out how efficiently you can move 64 byte chunks around between, you know, a grid, basically, of
Yes.
cores.
Yes.
So that's really mostly what that's for, because I don't want the false sharing. I don't want to not be thinking about. I also like to know how many of them there are, like how many of these cache lines is it going to take if I have to move this around, So I don't
Yeah.
know. That's just
Yeah.
something.
I mean, that's worth thinking about. I definitely think my nearer term concern is just getting it working at all. But
Yes.
again, speed is a deliverable of this compiler, and so whatever it takes to get the speed is
Yes.
what is the right thing.
And the other thing that I was going to say is for the arrays.
Yeah.
So
These are I would say just looking at these, um, I'm being a little bit cavalier with how much memory I'm using for them right now. I would say, like, because these don't like this thing is a structure that has like the things you would need in order to resize it and stuff, right? But the thing is, they get made early in compilation and don't really change. And so these could all
Okay,
be
good.
smaller, right?
I
These
wasn't
could
actually
be
thinking
like a count
size.
and a data or whatever.
I was just trying to think about like because sometimes dynamically sized arrays like that they stress me out because I'm like, well, for multi-threading that can be very dangerous. Like who's doing that and when. But if so, that's what I was going to ask. But it sounds like the answer is
Yeah.
a good is a reassuring one, which is that actually we probably won't have to care about that because these only get set once, so they're not like
Yes.
dynamically sizing during the run.
No, but
Um,
there is the case where like again, some of them get set earlier and some of them get set later and whatever, right?
which
So
seems okay though. I mean,
it's probably okay. I don't like until I start getting like I can almost guarantee that there's going to be some kind of really difficult to deal with situation, right? Although
yeah,
maybe not because we do run
okay,
thread sanitizer on the compiler once in a while, and the report is usually clean now. Once in a while we get something that's not good, but like so like if there was I mean, I guess obviously what I'm saying there is the order of operations is pretty well defined at this point, even if it's hard to think about because it's not made very clear.
well, and also the order of operations isn't as stressful to me as just it. Like, let's suppose that there was a dynamically resized array in here that multiple threads like add stuff to. That's very stressful,
Oh, yes.
right?
Yes, for sure.
Um,
Well, because
but
that's
if
going to be
that's
slow no matter what, even, right?
well,
Like,
and
even if
you
it's
probably it's
correct,
probably
it's
a first
slow.
class thing you're gonna have to think about. Like, how am
Yeah.
I gonna have to design something else, i.e., not a dynamic array, to work in here so that we don't, have problems with it. So if they're not that kind of thing, then it's a lot less stressful. If
Yeah.
it doesn't really matter when they happen, if they only happen once, that's a huge help,
Yeah, when
right?
you see these syntax tree nodes, pretty much all the members on them they're just decentralized and local, right? Like
Which is
mostly
great.
it's this node who cares about these things. And
Yeah.
yeah. So I don't know,
Yeah.
man. Maybe we've said everything that there is to say. I still don't know what I'm going to do tomorrow. Actually, maybe what I do is just while keeping in mind the kinds of things that we've talked about, what I could do is go to one of the phases that is not yet parallelized and just start
Yeah.
looking concretely at that specific problem without worrying about global data structure conversions.
Yeah.
So like, generating machine code uh, right now could be parallelized probably. It's got its own set of local issues, not even, you know, like, hey, you're going to call some other procedure from here. You kind of want to know the address of it or something, right? And it's not done yet, like that kind of thing.
Mm-hmm. Mm-hmm.
Which actually we sort of deal with right now, but it's more in a single threaded way where we say, okay, record the address of this jump offset and we'll come get it later, right?
Mm-hmm.
But that's just going to be a little different in parallel. Um, Maybe I just try to do that and just see what it turns into, right?
Yeah.
And just try to keep this stuff in mind. I don't know. Like in my head, what I had wanted to do tomorrow was just do some big attempted data structure conversion on the syntax trees, but I feel like I don't still know what that should really be.
It also feels premature. I mean, well, which is what you just said, but
Yeah.
uh, it feels premature from the standpoint of like the threading model usually dictates the data and not the other way around. So until I'd actually figured out some strategies for how I wanted to thread it, I don't think I could guess what the
Yeah.
data
Okay.
should look like, right? You know?
Yeah.
Because it's really non-obvious. You usually have to go like, okay, you know, let me think about how am I going to use 64 threads to type check this thing, right? Like, well, okay, let's do some analysis of like programs we've got. How separate are these things? How often do they do global lookups? Okay, what's my strategy for the global lookups? How do I want to do that? Run some tests. I run a lot of little sims, like I simulate stuff in C and then I go like, okay, here's the strategy I'm going to try, and then I test that out, right? And until I do that, I'm lying if I say I know what the data structure is, right?
Yeah, okay.
You might think you know, but you're probably wrong, right? And then you're like, oh yeah, no, that was dumb. It actually should look like this,
So you're
right?
saying I should play The Sims a lot. Does Sim City help too, or just The Sims
Yeah,
3?
I mean, The Sims and SimCity, totally. How come they never unified those? And so like people play SimCity online, and other people play The Sims living in that SimCity. I mean, how's that not happened?
I mean, I like looking at those games. It feels to me like they're barely able to make them as they
Yeah,
are, right?
that's true. Good point.
I don't know. Okay, well, this has
Point
given me a
taken.
lot to think about. Um,
Sorry
so
that it's basically not very useful for tomorrow's
no,
stream,
but
but
I mean, I sort of
you
expect
know,
because, like, look, you don't. If you had been thinking about this compiler for 7 years, you
right.
probably would have more concrete
Yes.
suggestions, right?
But this is the first I've really seen of this part of the code, so I'm just giving my first probably lousy
Yeah. Well,
suggestions.
like if I can actually parallelize the code generation tomorrow, like if I get that completely done, even though I won't, like my goal had been to try to attack the global problem because this has been something that of how do we thread the hard parts to thread. But this one is maybe a medium part to thread, and even just knocking that out will constitute some progress, and it'll make the compiler faster when you use that backend. So that'll be good. So yeah, I don't
I
know.
mean, you could totally do that, but I also think like again, if it were me, and even if I was like, I'm going to start threading the hard part of the code, right?
Yeah.
I would still start by threading the hard part of the code. Like I wouldn't feel comfortable changing the data structures at all until I actually played around with that a little bit, you know?
Yeah, well,
So
so what I think about that though is threading. Okay, so threading the hard part of the compiler
yeah.
is going to be about doing a big pass on data structures in some way anyway, not the way we've been talking about, but like being very clear about data structure hygiene in some way. Like what variables is the frickin' type checker reading, right? And
Mhm.
like when we thread it, what is it doing right now that we just can't do this way? And like I literally do not know because it's so much code, right? And so
Yeah.
figuring that out is important to do. And like I don't know what that looks like. Maybe it involves breaking it up into smaller pieces that still happen at the same time. Like maybe it's still doing the same thing, but like I just factor it into different files of like these are the parts of it that are not touching it, known not to touch external data or something. Like the infuriating thing is C++ really doesn't help you with this at all.
No, yeah, it
Um,
sucks at that. Yeah.
and
Like the things they give you for like public and private are totally not the kinds of code control you want.
no,
You want totally different code control than that, and they give you no features for it.
yeah. But
But
that's the other thing too is like, so this programming language is sort of designed by figuring out what C++ should have had, right? I mean,
yeah,
it's gone way beyond that, but that's sort of part of it, right?
yeah, yeah.
And so this would be the first time that I've done an extremely large, painful scrub of like how do I parallelize this code, right? And
Yeah.
I don't like yeah, I just don't know what that's going to look like. And I don't even really know how to start it because I mean, what do I even do? um
Well, so like for example, um, just to think about how I would probably do it. When it probably should look something like the second or third thing you said. Okay, I know that I've got a fairly sprawling piece of code, and I know that some of it is probably not particularly hard to thread, and that some of it is particularly hard to thread, but I just don't know where those things are. At that point, I often do a hygiene pass, but I do it on the functions, not on the data structures, you know?
yeah.
And so doing like what you said was like, what if I just say, look, tomorrow I'm going to start by going through, I'm going to start pulling out pieces of this thing that are leafy and isolated,
Yeah, well,
so that I
that's what
can
I was
see
thinking.
what they,
Like,
yeah, and that seems very productive
I
to me.
tried doing that once, and I didn't get very far. But
Uh-oh.
it
Okay.
like it's just or no, I would say I started doing it the other way around because I was like, okay, this is going to be a future. Like as I add new things, I'm going to try to categorize them. So I made this file called like thread safe helpers or whatever, where it was like these are just functions that you can call from anywhere and you don't care about, and like that file is still mostly empty. But
I like
I
it.
mean, maybe in part because it's not top of mind, right, when I write new things. But like the way that I'm thinking about what you said there is like, look, if I can make a, a, a file that has very few includes, right, that's a
Yeah.
sign that it doesn't need to see very much, right? And the problem is it needs to read data structures, right? So, like, it's just C++ just isn't very good at this is the problem. Like, I don't know, but at least I can minimize what it includes to some degree, like just cut it down. And that narrows the search space and makes it less confusing. I don't know.
Well, you can also try to, uh, like we were kind of talking about segregating things and making them be phase based. So like if the idea was we're sort of looking towards a future where we can look at that struct and see that there's certain things that happen in certain phases, you could imagine trying to do that. Like, okay, I'm going to try and organize this file, and I'm going to try and organize the data structure in the order in which it actually gets encountered by the type checker, so that I can just educate myself about how this actually ended up proceeding or something like that,
Yeah.
and maybe try to start, building that into a more concretely separated series of steps. You know,
Yeah.
um, I don't know if it's really. You said it was 20,000 lines of code, so that is pretty tough.
It's a lot. It's broken into a few parts, and some of them are so the part that actually does well. I don't know. There's a bunch of helper functions in here too, but like there's 12,000 lines that are like doing the actual activity of filling in the type slot based on what the thing is. That
Mm-hmm.
sounds like a lot, but like it's a complicated programming language.
Mm-hmm.
It used
Yeah.
to be a much bigger file, but I did factor out recently. There's a type matching query that you want to do all the time, right? Like, hey, we're doing plus. Does the left side of the plus and the right side of the plus even match? And if they do, is a cast necessary, right? And
Yeah.
that's more like a relatively clean function. It's still pretty complicated because we actually also use type matching for polymorphism solving when we do that kind of a thing. Like when you're calling a function with some type variables in it or something, we like call the type matcher and it matches the type variables to like the types of the things and fills in those slots. And who knows, maybe that should be totally separate code, but it doesn't seem like it. So the matching file is actually much smaller. It's like 2,300 lines. So that's more of a much more understandable subtask. And I think there's one or two other smaller things that I broke off. So like the actual polymorphism process that makes the new functions is like 3,000 lines. Like flatten was recently broken off. That's like 900 lines. So like I'm gradually chunking it into these
Yeah.
well-defined pieces, but each of
Yeah.
these pieces still is not threading clean in the sense that like I know what the fuck is going on, right?
Right. Right. Sure.
And then what I'm saying is all these files together sort of make this type matching pass, and it's probably about 20,000 lines altogether, ish.
Okay. Yeah. I mean, yeah. I get it. I get why this is not going to be fun.
Yeah. I
Uh,
could be like every other programming language and just now port the compiler to my own language. But the problem there is I want to use this to inform the feature set that we support, right? And like, if we don't support it yet, there's not that much advantage to like porting the compiler. Also, I don't want the huge like year-long roadblock of now we're redoing the whole compiler from scratch. So
Yeah, I've never really found that to be particularly interesting anyway, because it's like, I mean, at some point, I guess it makes sense, but the time when you probably wanted the language was when you were starting,
yeah,
because like
exactly.
you've already done
Exactly.
most of the hard work of just dealing with C++ crap to get to this point.
Yeah.
You'll save some, you'll make it more mutable and easier to work with, but you already kind of suffered a lot,
Yeah.
and that really can't be helped. So
Yeah. So but it's interesting because I can at least, so even if C++ doesn't really help me do the analysis, I could even write at the top of these files what analysis I wish I could do, right? Like
right, yeah,
at this point, here is what I don't have high confidence about
right,
and wish I could see. And that'll just be useful information, right?
right. Like you want a thing that, for what you were kind of talking, was like at the top of the function, you want to be able to say, I expect you to be able to read from these fields and write to these fields,
Yeah.
but not the other way around. So if you see
Yes.
anyone assigned to that field, you need to tell me,
Yeah.
right? Um, so yeah.
All right, man. Good
All right.
conversation.
Well,
Thanks
good
for
luck
doing this.
tomorrow.
Yeah, we'll see
Oh, no
how it
problem.
goes. Maybe it's going to be a complete disaster. Maybe it'll be a part. I mean, if I manage to multi-thread, like if I go the route, I could imagine doing some of each of these tasks tomorrow, right? Because like I just decided I'm going to spend all day attacking this problem and make some
Okay.
progress on it. So that's why it's a marathon stream. And maybe I'll try one thing and get sick of it and try another thing, and we'll just see what happens.
And the idea is just a marathon stream of trying to move the threading model forward, like get something better.
Yeah, because okay, so developing a big project like this, a lot of the time you're just behind on the to-do list, right? Or all the time you're
Sir.
just behind. And
Yeah.
but the thing is, if you let yourself be defined as the person who's behind on the to-do list, you just kind of drown in that and die, right? Like you
Okay.
have to,
Okay.
like there are some points where it's like, okay, there's still a lot on the to-do list, but also a lot of other, like the waves go up and down of like how urgent the things are on the to-do list, or like, hey, I just got a bunch of progress done and it feels pretty good and some questions are answered. And at those times, um, when the pressure is lowered, it really helps to just go attack some of these looming longer term questions, even if you don't intend to
I
solve
see.
it, because it's like, look, I'm just going to make this progress right now. I'm just going to put a bunch of energy tomorrow into making this progress as much as I
Got it.
can, because otherwise it never happens, is kind of what I'm saying, right?
So it's kind of a strike while the iron is hot kind of a philosophy. It's like this is a hard thing to do, so I should try to do it on a time when it feels like momentum is positive, rather than when it feels like momentum is negative or something, when it
Yes.
will be much harder
Like
to
if,
make.
if you're drowning in bug reports from people, you're not going to
Yeah.
want to restructure the compiler, right?
Right.
Because
Yep.
like, oh my God, right?
Yes.
Yes.
Yes. Yep.
So yeah,
Makes perfect
that's just
sense.
what I was feeling like this weekend, and so we're gonna do that, and we're gonna see what happens.
Well, cool. I apologize for not having anything particularly constructive to say, but I wish you luck tomorrow.
Okay, I'll let you know how it goes. Thanks for talking. It's been a long. Steam doesn't have a little clock on it, but I feel like that was like 2 hours or something.
It is 2 hours and 30 minutes.
Wow. Okay. Well, see you later, man.
Good talking to you, man. Take it easy.
See you. All right. Thanks everybody who has been hanging out listening to this. Are there any questions about what me and Casey were talking about? I'm probably going to end the stream soon so I can get my beauty sleep prior to the next thing. But yeah, any questions on what we discussed or how disgusting we are? That is also a thing you could ask. What time am I starting tomorrow? I do not know. My guess that I told somebody else earlier was 9:30-ish, but honestly I don't know. How disgusting am I? 9.3 out of 10. Did I come to a conclusion how I wanted to deal with the lookup multi-threading? Not totally. I mean, for me, I'm not that worried. Like, identifier lookup is a very isolated problem. So, like, even if I solve that with something that's slow in the beginning or inconvenient, it at least can be done, like, because there's one point of contact there, it's maybe not that worrisome. Like speed, making it as fast as possible is worrisome, but getting it to work at all maybe isn't. What I'm more worried about is just like stuff that happens during type checking that's not identifier lookup, that's like using all kinds of global state in some way, somehow. Yeah, I would say that that's a pretty good summary of the two investigation axes, sort of. Like the problem, so the problem is when things are single threaded, you don't really have to think about what globals am I reading and when, I mean, you do actually, it's an oversimplification to say that because you do, right? Like if you read a global, you need to know the meaning of the value that you read. And so if that could change after you return and whatever, you do kind of need to know that. But you don't need to be as strict about those things. The fact that things are implicitly serialized helps a lot sometimes. And so there's just a thing when you go parallel that like a lot of the things I'm doing are not going to be okay at that point, and I need to figure out what those are, and it's just very hard to audit that. No, in telemetry, uh, this thing here at the with most of the activity in it is the actual compilation thread. This one up here that's mostly red is one of the metaprograms. This one that's mostly red is the default metaprogram that lives outside your metaprogram. This one down here, the message export 3, that's just sending messages to your metaprogram. This one is sending messages to the default metaprogram. And all these are parsing up here. And really the parsing threads probably could be made. Like we could decrease latency probably by increasing the speed of parsing somehow. Although, I don't know. I mean, it's pretty well defined. Like stuff happens and then we get new stuff coming in. I don't know. I'm actually not sure. What I don't understand is why, for example, is there this big hole here or even this big hole? Because it seems like all of these guys are waiting for work and then a bunch of parse jobs come out. And, this could be default metaprogram and this is your actual, I think that's what it is. Here we're parsing startup stuff and default metaprogram stuff. And then here is probably where your actual program starts compiling, which is like almost a frickin' 100 milliseconds in, which seems like a long time. Although this is telemetry build, so it's slower than regular. You're surprised to hear identifiers aren't interned. No, they are not completely interned. No. They're kind of semi-interned. could it be an OS scheduler I don't know what that is referring to. The thing is, storing a bunch of pointers to members of structs, that storage has to live somewhere, and that's expensive. Yeah, okay. I think the first thing I'm going to do tomorrow is like back off on this hash table. Right, it's a lot of clocks. It's expensive. And then from there we could see. I'm just looking at various things now. What would replace a hash table? We would just go back to just having a pointer on the base node for each of these. That's a pretty straightforward thing to do. Look at all those purple polymorphs. Anyway, I think it's bedtime for me, folks. Thanks for hanging out. We're going to do an all-day stream tomorrow from whenever I wake up to whenever we are tired. And the goal will be hammering on performance of the compiler and just moving it forward in some way. And maybe, let me just check real fast. Do we have any nastygram bug reports? I think we let slip a new, oh no, oh no. We've got some compiler crashes we could work on. They don't seem that bad. They don't seem that bad. So we'll see. We could do that. All right. Thanks, everybody. Have a good night. Is it fair to say that the benefits of multi-threading comes only if the task is CPU bound? No. Okay. The thing to realize is there are different memory channels to different CPUs. So you can actually get more memory bandwidth as well. Although I guess from what you're asking, it's complicated. Like if you're CPU bound or if you're memory bound, you can improve by going multi-threaded. But again, like the answer to that is very system dependent as well. All right. Good night, everybody. See you later.